We are back live. Hi. We have some experiments to check, and finally it looks like we no longer have crashing. I mean, those are nice, right? Those are very nice. This doesn't have the new grad norm stuff in it, but we get them some graphs. What is this one? Okay, so this is set beta to 0.96. And just put this on the stream as well. What else? Cool. Interesting that it increased the preconditioning learning rate, because they all told me to decrease it. Goes to show you that intuition does not match. Like, intuition really doesn't help you at the moment in a lot of these things. And by intuition, I mean like the way you would think it would work based on the math. Doesn't always happen that way. But hey, this is cool. So I think we let this this sweep keep going for a bit, and then what I'll do is tonight I'll queue up a long run looking for the best params. So we haven't checked in on our best run in a while, have we? So if I just do this. Oh, it's almost done. Almost done. This is stable over the whole thing so far as well. To 4.12. I checked it before, 3.7. That's nice. Very solid curve. All right. That's very weird. I'll have to look at that. Okay. My head's a little fuzzy at the moment with these results because things don't all behave the way I expected. I mean, it looks like we're getting good results, so I think what I want to do here for a bit is kind of just hang out and talk through out loud a little bit of what all this could mean and where to go from here. So let's start with muon. This baseline is muon. We tuned muon for breakout, and then roughly the same hyperparameters worked on everything else. Actually, I don't know about this one. I think we had to, except this one. This one, I think we had to use a few different things. But basically, all the other M's muon worked pretty much out of the box, with a few hyperparam tweaks that you would more or less expect to have to make. Felt very, very stable and consistent. Now, with neural MMO3, it didn't quite work out of the box. So I went and I used the old tuned neural MMO params. Hey, Linky, yeah, I gotta look at that. Let me finish thinking. I want to finish thinking through this first because I got this on my mind. I think. So, I'm pretty sure this is the old tuned params, right? This one right here. Just double check. Make sure I'm looking at this correctly. Yeah, you can see these are the old tuned neural MMO params. And that gives you this state-of-the-art here. So why do we need to tune the params for neural MMO but not for anything else? Well, one option is it was the batch size. So I think I tried that. Mini batch size, rather. I don't know if I tried with muon, though. Just doing like 32K mini batch. Might have actually. I guess the question is how much do you actually have to change the hypers to get it to work on neural MMO3, right? So the mini batch one, that's kind of explainable. It's related to the How AI Training Scales paper. And it seems that from my initial results here, you kind of just want to keep increasing the mini batch size until you hit a critical point, which depends on the environment. And for neural MMO, it's clearly just higher. So, I mean, that's a good reason for me to go implement gradient accumulation, because the mini batches are getting too high to do in one pass. Probably actually will be slower to do them in one pass at some point. And then we'll be able to tune that parameter higher. But the original did work relatively well without any of that noise, right? Or did it? How well did the original work, actually? Because this is the only baseline we have any reason to expect to beat, right? We only get up to like 2.5 and 100 mil. If I look at like 20, it's like 2.25. Okay. So, and that's right around here. And again, we didn't tune muon for this env. I don't know if I ran it long enough. I guess I can't really say for sure that it doesn't work with roughly the same hypers. It's pretty likely that it works with similar hypers at the least. Learning rate 0025 was the best for PSGD, but that's a different algorithm. Okay. See, what I really would like is to have something that just feels stable and works across a bunch of different ranges. Mini batch, it seems, is going to have to just be tuned. You know, it starts at 8192. You start it at whatever's hardware efficient, and then it goes up from there is fine. What about batch size? Probably also gets tuned, right? Usually will work out of the box, but it gets tuned. Because that gives you data staleness. So if you have a really big batch size, right, you start getting more and more off policy. It'll be interesting to actually see what the optimal mini batch size ends up being if I just rerun these experiments with gradient accumulation. I think we definitely do that today. Not run the full experiment, but at least implement the gradient accumulation. I mean, even if this thing does level out eventually, right? Like, this would still be, if let's say that this does it in, I mean, this is like 100x more sample efficient actually than the original baseline. If I had it on the same plot, because it took maybe 50x more sample efficient actually, because it levels out. The original levels out at 2.5 with like the same everything else. I don't actually think that the algorithm is 100 times better as much as it's probably 100 times less fiddly. So it's probably just easier to find good settings. Plus, we give it a little credit. There are a few nice things it does as well. So like priorities wise here, gradient accumulation is really easy to implement. I can just do that. It won't take me very long. There are more algorithms to try. I don't think I want to do that just yet, though, until I finish getting these sweeps. I guess the two options would be we kind of like lock in this stuff and we say, okay, you know, once we get this to work, we're going to run like really large scale experiments with this method to see how stable we can get all of our M's. And the other option would be to keep going ahead and try to get GGAE working, or P3O. Wait, what? I'm confused. I guess he's watching stream or was. Variance correction, so similar idea. in a diffusion model with batch size 4. All right, well, we'll try with and without on the optimized settings. I legit don't tune any except for LR. So no idea. You gotta tune your params, man. Gotta tune your hypers. Protein algorithm. I like it. So we'll try Mars. I doubt it solves fully like just the mini batch thing, but we can see. Get puffed up with protein, yeah. Funny. Okay. The other thing, I think that I kind of should just start running these like large scale sweeps and stuff. But the generalized advantage estimation thing bothers me. That param is still going to need to change a bit. I mean, I could fix the param and see what happens. Let's look at some of these curves. So they have lambda here. Lambda equals 1. Lambda equals 0. Oh, 0.85, 0.92. These seem good. 0.98. It's down there. Needing both of these tuned is really obnoxious. Though, I mean, admittedly, right, if you're just not too worried. But this is no value function. Is lambda, was this gamma equals 1? So that's reinforce. So it's possible to underperform reinforce here if you don't tune these. I mean, in practice, though, it seems like it's always just a bit lower than gamma. Like 9.6 here. And then this is 1.0. So yeah, there's no way in hell you can have the same gammas and lambdas for everything. Even if it's working in our case, right? It's probably just working because we have a ludicrous x-axis. I don't think if I can do this in segments, though. Does it make sense that entropy needs to be tuned per task? Maybe we don't worry about those three so much, actually. If we don't worry about those three parameters a ton, because we assume that we're going to do algorithmic follow-up, then what's left, right? You have your optimizer params. I mean, fundamentally, this is all like... The question is, if you tune everything, how much better can you do than if you, like, fix a bunch of defaults? I mean, I could realistically, right? 500 mil is a bit short for neural MMO3. But I could realistically do like a neural MMO 1 bill benchmark. And I could full sweep everything. Okay, well then here's another question, right? So if I then take the neural MMO params, maybe those work on the simpler M's, right? Maybe the simpler M-tune params don't work on neural MMO, but maybe the neural MMO params work on the simpler M's. I was playing around with 00025 for this. So it's 0025 is the optimal learning rate. So what if I just do this? Recon. Does this solve breakout? Actually, let's not do the stupid mini batch thing as well. Yeah, it's reasonable params. Let's go find the Neptune plot for this. That actually works better than before, doesn't it? Yeah, that works a little better than before. This one is not comparable. This one's slower in wall clock. So this actually does work. Hey man, welcome. Congrats on the end. I saw that. I think, did I review the code for that or no? No, you haven't. Okay. Well, if I don't know if it's open source, but if you're interested in PRing new env to Puffer, we will be very happy to get you set up with all sorts of fun sweeps and stuff on that. Let me link you the repo. Awesome. Yeah, up to you what you want to do. Pretty much for any new contributions, I'll do at least like one full pass line by line code review if you want it. And I also help with integration. And then the end just becomes, part of the Puffer test suite, and you can, it gets optimized aggressively with all our stuff. Just want to learn and contribute as much as I can. Well, I mean, this is a good way to do it, right? If you make the env a part of the benchmark, right, then every time we come up with a new method, or every time we come up with something new in Puffer, we just will throw it on that. So like, for instance, yesterday, right, I was doing work with muon and PSGD, and I ran both algorithms on every single env in Puffer. Cool. That's not bad. Is it ready for code review, or do I hold off? Like, what? How would you like me to do this? Because I can go through this right now line by line if it's useful, and then just PR directly. Should be ready. Okay. If you got a minute, let me go make myself a new cup of tea so I wake up a little bit, and then we will go through. We'll do a full review. We'll get it PR'd. Any little things that need to be fixed, we can fix, and then we'll throw our latest algorithms at it and see how much better of a policy we can learn for you. Bit masking, not optimal, could be replaced. All right, well, we'll see how fast it is. I'll run some tests on it. It'll be fun. Let me get myself a cup of tea, though. Okay. So, if you want, you can jump on Discord, and we can do this through voice if you don't mind being on stream. Otherwise, I can just review it like this. Your choice. All right. Great. That makes it a lot easier. We do pay for the nice voice channels. Hello.
Hello.
Hey, how's it going, man?
Yeah, good.
Cool looking end. I'm excited to try this out.
Thank you. Yeah.
Let me see. I'm probably going to do a quick, once through, make sure that it looks good first. And then I'll probably just, let me see. What's the easiest way to do this? I guess I'll do the line by line first. Actually, the one thing is I want to know how it works before I review it fully. So I'm trying to think what the easiest way is for me to try it. I guess I can just grab your build real quick before I PR it. Hang on.
Just be aware that since I'm only running on CPU, in the config.ini file, I've set up the CPU by default, so you might want to override that.
That is totally fine. Yeah, definitely if you're looking to get into a bunch of RL stuff, this is a place to be. We're a little low on hardware now, but the goal is that we will be providing hardware to all contributors as well for experiments, for stuff they'll be contributing. Cool. So.
Yeah, I've heard there's a lot of boxes on the way.
They're not on the way yet. We have one test machine. I got to make sure the 5090 boxes are good before we put in a big order. Because there's some sketchy reports of some hardware issues with those, and we've dealt with enough hardware issues already, believe me. But yeah, I think we should be getting a couple boxes back anyways, so. What end is this? We are just reviewing this end right now. Brand new contribution. I actually don't know exactly what it is yet, so I'm going to see.
I can talk you through if you'd like, or otherwise I just let you.
Let me first. What's it called? CPR.
CPR. Yeah.
PufferLib Ocean. Is it a different branch? Oh, it is a different branch. Okay. Awesome. So we got some puffers running around. Does CPR, first of all, what does it stand for? It's not a medical end, right?
No, it's called a common pool resource. So
I see.
As you see, yeah, there are two different types of foods. The gray one, which can be collected just by going on the same cell as the foods. And the yellow ones need two agents to stand next to them to be harvested.
Oh, okay.
And
cool.
And they reward more, obviously. And then there's the respawn. So there's you can basically deplete the entire resource because the food can only respawn next to another food. There's just a very, very low probability of a food to randomly spawn somewhere on the map. But other than that, you can basically learn to harvest super efficiently and completely deplete the resource, and therefore you're left with nothing.
Okay. This is a good end. This is a good environment. This is like a cool new type of a test. I like this.
There's still a lot of work to do. I mean, I would like to put some health on the puffers and and make them able to die and give them bad reward and then die, something like that, just to make it more like
It's not
push
that
them
hard.
towards. No, I don't think it's hard. Yeah, it's just I've got a couple of things on the list to do basically.
So let me go through this code. I think we'll just make this, PR this thing, press. I might have to do a manual merge because it seems like a fair bit of stuff has changed. Is that all right?
I think you can skip all the ini files. Expect. Oh, it's because okay.
Yeah, but
I know why. It's because
I can't change it in your PR. I don't think, right? So I can just copy this folder and I can do the merge manually, or if you want to do that, so you know you show up on the contributors on GitHub, that's fine too. You'll go on the website either way.
No, it's just yeah, it's fine. Whatever for me. Just what's easier for
Okay.
you. I mean, I know I'm on a older commit from the dev branch, so that might be why there's a lot of changes. But
Inflated puff. Honestly, I can probably just, because the only thing you merged is the only thing that you changed. Yeah, you changed like a couple small things that I can just undo, I think.
yeah, I think this one in demo, that's one of the PR I made too. It's just so I wanted to abstract the Neptune workspace into a ini file, but it doesn't have to be in that PR. And I made one about yeah, okay, yeah, I made that one,
Oh,
which
that's
should
actually
be
fine. That's actually a good contribution anyways. Yeah, the only thing is that this metric should go into the into your file, not here. That's fine though. Okay, comment. Yeah, I'll just undo those. No big deal.
I mean, let me know whatever is easier for
Yeah, this
you
is.
if you need me to
I
work.
can deal either way. It's not hard. We're good. Okay, so you have. Yeah, this makes it the only thing with doing this type of thing, because I did this with my snake env as well to have like variable size in the same experiment, and it's really cool. You can do it, but it does make it a little hard to sweep over. Because like,
Okay,
how do you sweep like different combinations of
yeah,
maps in the same experiment? I mean, you can keep it either way. I'll show you what I did with Neural MMO3. Like, I kept this
okay.
in Neural MMO3, but I just made it so that here. I'll show you how I did it with Neural MMO3. We've been running more experiments on that the last couple of days. So all I did here is it has width and height, and it also has num-emps. I just made width and height. Like, you're not going to need more than 8 of these because there are a ton of agents each. So you can just make this longer, and I just like prune it to the number of emps. That's an easy way of doing it.
Okay.
Yeah, that's an easy way of doing it. Let's get through your code. Where is it? Where'd it go? I have too much stuff open. Seriously, where did I just secure PR? There we go. Okay, so you've got some parameters. These are all fine. Tiny number of time steps.
Okay, yeah, I might have not pushed the latest,
Tiny.
the one I used to train with, but
Yeah.
yeah,
I mean,
I
I'm
can do it
sure
now.
if you're training on CPU, I'm pretty sure that whatever result you have will be able to improve on very, very quickly.
Yeah,
Just
yeah,
because you're
because
doing them fast.
300 million time steps train took me about 45 minutes. So
300 million time steps on an optimized M should take under 5 minutes.
yeah,
with
I mean, I was running on like 100K steps per second on my CPU, basically.
yeah. So GPU version, if the M is optimized, will be much faster.
Cool.
These are fine. Mhm.
Arik on the .c file is actually never really used apart from when you're testing stuff from C directly, right?
Yeah,
Yeah.
but I do that a lot. I don't know if
Hmm.
that's how you dev your environments, but I do all the
Yeah,
environment dev in C, and then I only bind to Puffer when it's ready because it's way faster to compile and you get better error messages.
yeah, yeah. I ended up doing the same, but that was the first time I started touching C for my entire life. So at first I wanted to do it in Python, but I just ended up doing
Mhm.
everything in C afterwards.
You end up realizing very quickly it's not as scary as you've been told.
Hmm.
I wrote Python for 10 years, and then over the summer I just started writing pure C, and it's like, oh yeah, this is chill. Yeah, Captain, new NPR. Okay, so we've got some bit stuff. Um, yeah, this type of stuff is fine. I'm not a big fan of macros. I'd rather just have an inline function, but no big deal. Here's my logging. This isn't logging anything though. Oh wait, no, it's
What do you
down
mean?
here. I'm done. Yeah, I'm
Yeah.
done. It's down here. Okay, so you got score. Yeah, you definitely want score. Moves. Is this episode length?
No, move is the should be the average number of steps each agent takes before reaching before getting rewarded one food, one or the other.
Does the M just never reset?
No, it never does.
Yeah, that's fine then. Agent has R, C, and ID. So you just made a vector.
Yeah, I figured so. When I need to spawn to make the spawn food mechanic,
Mhm.
I need to put the food spawn on next to each other. So I need to iterate through the food, and I would rather have a food list rather than iterate through each grid cell.
When you spawn the food, well, the way that I would do that is I would just, I'd pick a random, wait, they have to spawn next to each other, you said. Oh, okay.
Yes, yes.
Yes. Um,
So basically, for
yeah, in
each
that case,
food
it's
that
fine.
yeah.
In that case, that's fine. Yeah, okay. Well, let me see how this is. So you allocate. Okay, so yeah, okay. So this is a fixed array. You're not doing dynamic anything. It's just this is fixed. Yeah, that's fine then. That's fine. That looks like pretty normal grid code. What's this interactive food agent count?
Yeah, so that's the thing I'm pretty sure I'm like almost 90% sure I could remove. So for the interactive food, the yellow food, it needs to have two agents next to it to be collected.
Mm-hmm.
And initially, I started having just so a bit masking for it, setting the bit to 1 for it to be ready to collect if an agent is next to it. But then I figured I could just basically look at the squares next to the
Yes.
food and count the number of agents. But yeah,
Yeah, that will probably be easier.
yeah.
Called by C stuff. Yep, this is, well, yeah, this is called, yep, this is the allocated version. That's fine. Agent tile from ID. This is some offset, it looks like.
Yes.
Okay, I've done the same sort of thing before. Agent ID from tile. Okay. Food. This can duplicate, can't it?
Mm,
If it, what happens if there's a food on the tile already?
um, I think you're right. I mean, I'm definitely checking if the tile is empty before calling that function, but I
Oh,
think
okay,
you're
then
right,
that's
maybe.
fine. Yeah. Yeah, it's just, this will duplicate. Yeah, that's fine. If you're checking that it outside, that's also fine. Uh,
For the when we reset the environment, I still need to randomly spawn some food at some point.
Man, I miss do whiles in Python because they're so nice sometimes. Uh, all right, remove food. Yeah, so this is going to be the if there are performance issues with this end, it's going to be from this type of a thing, of like making it um, O of n, like O of num food to do stuff. I think it's probably simple enough that stuff's going to still be fast regardless. Um,
Okay.
but this type of thing is like, let's say that you just want to make a really cool demo of this environment. How would you do it with like the least amount of effort?
Well, you probably put like a much bigger grid and
Right? Yeah,
yeah.
exactly. So if doing this type of stuff, if you go, shoot, that's not going to scale well if I try to make the map super big.
Mm.
So this is the one type of thing where you might want to rethink data structures in it.
Okay.
It'll be fine as is, but let's say you wanted to do like the snake demo that I have. Like this is a really fun demo.
Because yes, the reason I made the food list is because I reckon it would just use a bit more of memory, but it's just ON for going through the each food instead of going through the entire grid, which should be a bit longer. But
Moves food from the grid and food list.
the thing is, for each food that is already on the grid,
Mm-hmm.
there is a small probability of a new food spawning next to each other. So at some point, I need to iterate over each food that
Yeah,
is
I
already on
see.
the grid.
There's got to be a good data structure for that. I'm blanking on that at the moment, but there's got to be a better data structure for that. I'll think
Okay.
about that. Um, yeah, there might be like some combination of just like a food grid and some indexing, or I don't know. We'll think of something.
Okay.
Um, Because like this would actually be a really cool M to have a big version of.
Yeah, I've tried to make it big, and I mean, if the agents were acting randomly, but at least you can see some very cool patterns where the food spawn next to each other in some spots, and it looks very good.
So this is just trying to figure out how many food to spawn based on how big the map is, right?
Yeah, I tried. It's probably not perfect yet, but it looks all right for a couple of different tests.
Isn't this the spawn food function?
Oh, yeah.
Yeah, this is exactly the spawn food function.
Yeah.
And this again would be the spawn food
Yeah.
function if you just add a
Yeah.
parameter. You just add a parameter, which is the type to spawn, right?
Yeah,
You
you're
should be
100%
good.
right.
So this would get all compacted, which would be nice. Spawn foods.
Hello.
Hey, how's it going?
Pretty good.
We can
Wait, I
chat
just
optimizer stuff after I finish. We're reviewing this on stream. I don't know if you have it open.
Oh, okay, for sure. No, I didn't. I just hopped on.
Yeah, no, you're good. I got experiments running for you. I'm reviewing. There's a cool new M contribution by M1000 here.
I'm excited to see. I'll hop on stream really quickly.
I'm going through the code first, and then we're gonna see if we can get it bound nicely to Puffer, and then hey, we'll throw your optimizers at it because why not?
Hell yeah.
So we have very minor pet peeve. Please do force space indents for Puffer code submissions, if you don't mind. The point of it, right, is that when you nest a whole bunch of loops, that you actually have to see that you've made Kamehameha here, and then you think about your life choices. You got the like this arc here. It's the the Kamehameha with the code.
Yeah.
Yeah, of course.
So how would you
Well, it's not
rather
necessarily
have me
bad.
doing it?
It's not necessarily bad that it is, right? But I'd rather see it, and I'd also rather not screw up what code's aligned with what other code. So that's just what we do by default. Let me see. Is anything
So funny. I have
okay?
4
So
laptops
the
open
only
right
thing that I
now.
would get rid of is this is trivially if it's not empty, continue. Right. So early continue or early return. This is the one pattern I try to drill into everyone is if you have a trivial statement, then don't nest deeper for no reason. But everything else here is fine. There's no like triple for loop for something like this is totally acceptable. I don't understand. Like people don't get that for some reason. It's not that deeply nested code is bad. It's the deeply nested code that doesn't actually logically need to be nested is bad. Like I don't know. I posted. It was like the weirdest thing. I posted this snippet on Twitter at one point, and I said, "It's not pretty, but it gets the job done." Right? It's like I posted like, "Yeah, this isn't great, but it gets the job done." And I posted this, and people were like, "Oh, it's so bad because the nesting, you gotta do the nesting." It's like, no, the thing I was referring to is that it doesn't do tiled matrix multiplications. That's why it's bad. Like a conv is just going to have this many loops because that's what a conv is, right?
Yeah.
Like,
Do FFTs, bro.
yeah, just replace all convolutions in AI with FFTs, BRB.
Yeah.
All right, so
They're not actually always faster either.
No, of course not. You can keep your switch statements if you like. I don't use them, but I do not ban them.
Okay.
Because they're like it's normal code. That's just me being a little pedantic.
switch statements.
I don't like switch statements.
I could never wrap my brain around switch
It's because of the
statements.
fucking early returns, right? Like if you miss a break,
Yeah.
you're screwed. And then it's like this weird thing where you like by default you don't indent it as well, even like it's driving
Yeah.
me nuts.
No, switch statements always I was like, yeah, I'll just be basic, sorry.
This is fine though. Otherwise, this is fine. No, maybe I would like put the rand up here. Maybe I'd put it. Wait, actually, hold on. Is it wait if case normal? Wait, is this wrong? Wait, double rand, but base food spawn. Wait. Is this supposed to be two separate probability checks, or is it supposed to be? Is this supposed to be two separate probability checks, or?
No, because I'm only checking one at a time. So the probability check should be run one at if on the grid index. But yeah.
Okay.
So I could definitely put the double rand max
Yeah. Well, I
right
don't
after
know.
the switch.
Yeah, it depends, right? Because if you do food base spawn rate for 10, if it's less than and food base. Yeah, okay. It's whatever. If it's I don't know if these should be grouped or not. Depends what you're trying to do.
Yes. We just made a novel optimizer.
Oh, well,
So
we'll go try it.
yeah, it's like novel, like I think it's novel in the sense that like it hasn't been done even by Newton or anybody since.
Ooh. Well, we will see if it works.
Yep.
I have very hard test times for you. I'm like looking at this code, seeing if it's like self-similar, but actually, no, you are trying to do two separate probability checks, it looks like here, so this is fine. Right? This is two separate probability checks. So this is fine.
Yeah, but I guess I
That's
could
fine.
do it in one, but
You don't have to. It's fine. You don't need to cache stuff if you want two separate checks like that, that's fine. Compute observations. Does this handle padding? Wait. How does
what do you mean?
this
Sorry.
agent R minus M vision?
Yeah.
Grid index. This can't this go negative? Can't this go off the board, or is the environment itself padded around the edges?
Yeah, it is.
Okay. Yeah, so either way is fine. I guess you just don't render the padding, is that what it is?
Yep.
Yeah, okay. Either is fine. I've done both. I either will just like pad and not render the padding, or if I don't want to deal with like a border dimension, I just suck it up and I write the the checks for the window that you want to actually go over. I've done it both ways.
Well, actually, I think I'm rendering the padding as white boxes. I just need to make sure of that. But
Okay, and then we have reset here. Gotcha. Well, I guess it's a gotcha, but it doesn't really matter because this env is not designed to reset midway through anyways. So this function does not have to be fast, but this is just a memset. Right.
oh, yeah.
This is literally just a memset to empty, and it's way faster as well. This is a what?
No, but that's correct.
This is probably this is a memset. Like most of these are going to be memsets. A couple of these are not in contiguous memory, right? So like the vertical ones are not in contiguous memory, but the rest of them are. So that's how you do fast map reset.
Oh, okay.
And
Great,
actually,
thanks.
if you want to be really smart about it, what you do is you save a default map, right? So you save the empty map, and then you just memset or you mem copy the entire empty map, right? You just mem copy the entire.
Okay.
So that's if you wanted to do faster resets, that's what you would do. And then the map scale kind of matters because if it's like a really sparse and empty map, right, then it's faster to just memset the walls and loop. But if you have smaller maps, it's faster to copy the whole thing. But it doesn't matter unless you're doing like frequent resets. But if you are going to do frequent resets on any end like this, then it matters a lot because reset is where you can leak a lot of performance.
Okay, thanks.
So even though not applicable here, I try to tell people when they submit code, I try to tell people like the common pitfalls, like, if you do a similar environment that works just a little differently, just be aware you can shoot yourself in the foot here.
No, that's great tips.
Yeah.
Thanks.
SRAND. I don't usually see it inside the end like this, but I think you can. Yeah, you can. That's fine. It really depends on the end whether it matters or not. You're going to get RNG from the actions from the policy anyways. Okay, agent. Good. What is this? Wait, agents. This is in reset. We go through the agents. While not allocated.
Yeah, we just place the agents in a grid somewhere.
Oh, okay. Yeah, so this is like. Okay, yeah, this looks a little different from the earlier. This is the same as the do while code for the spawn food.
Yeah, you're right.
Yeah, all grid code is going to look like that. That's fine. Get agent tile from ID. Yada yada. You do know what a memset is. Look at that.
Yeah, that's my first writing in C, so
Yeah.
I learned a little bit along the way.
Yeah. Well, what we try to do is, I don't know if you noticed from the code style of a lot of the M's, but I don't do anything fancy, right? Like all the stuff that I do, even in like Neural MMO 3, I don't do anything that you're not going to see in your literal first undergrad course. If you're to take one undergrad systems course in C, you'll see everything I do. And in fact, I only do a very small subset of what you'll even see there. It's basically like if you know what loops and conditionals are, and you do have to know what a pointer is, but that's about it. Then you can read the code. That's the goal. Just really simple. Board agents near. Oh, we have a fair few folks on Twitch watching this. Hello, welcome. Code review for new environment being contributed to PufferLib. I do this for all contributions if folks are interested. Reward agents near. Had to head out. We'll be back. Ping me when you do optimizer stuff. Cool. Okay, so this is checking if you're next to food, I assume.
Yeah, so that's being called only when there's two agents next to the food, and then we just basically iterate through what's next. Yeah.
It gets reward, it gets score. One small thing that I would do here is I would probably make the score +1 instead of plus the reward, because then what you can do is when you specify what the reward coefficient is, let's say you put this coefficient into a hyperparam sweep, right, to see what reward scale is going to work the best, then you can actually compare runs directly with score. But if not, the score is going to depend on. So you always want to have a score metric that ideally doesn't depend on the reward, right? Or the scale of the reward.
But if I still want to scale the score based on type of food that's getting rewarded, I can just hard code it like a 2 and 1 for normal food, and that's fine, yeah?
Yeah. So you think of score as like points you would get in a game, and reward is separate, right? Like the amount that you're going to actually give to the agent for training could be different from the score.
Okay.
Though generally, if they're both 1 anyways, it'll probably be fine. But
I get what you're saying, because if you start to sweep the rewards, then you just end up finding just put the max reward. Right?
Exactly. And if you only have one source of reward and it's fine to just always have that be 1, because then you'll just adapt the learning rate and stuff around it. You don't need to sweep the coefficient is 0 to 1. You can just always have it be 1, But if you have a bunch of different rewards and you don't know how much they matter relative to each other, then that's when you need to start thinking about this.
Gotcha.
So, step agent. Yep. Is this a no-op? Is there, I think there is a no-op, right?
What do you mean?
Like this is, wait, if action not equal, so 4 I assume is no-op?
Yeah.
No-op, yeah, it means don't do anything.
Oh, yeah. Sorry.
Okay. Can that go wrong in any way? The only way that this can go wrong, for reference here, I guess you're going to have this problem either way, but so the way that the sweeps work, right, it's going to wait until you get metrics back from logging in order for it to like, it needs to like keep running steps until it gets metrics, right?
Mm-hmm.
So if the agents don't ever get any reward, or they don't ever like complete a log, they never get anything, so they never trigger add log, then the run will basically hang. So
Okay, so
in
that would
this,
happen if the agent doesn't do anything, basically.
yeah. So like in breakout, for instance, I had to delete the no op action because it could just choose to sit there and the episodes would go on forever. Now, this is not quite the same for you because your episodes are designed to go on forever. So you're probably going to need some sort of safeguard where like if nobody gets any reward for 128 steps or something, you got to return a log of all zeros.
Okay.
So like that's the one thing is you're going to probably have to spot check that because I think that this likely it's not guaranteed to break in sweeps either, but if you get bad enough hyperparameters it can break, right? If
Okay.
basically if you get hyperparams that are so bad that the agent just decides I'm going to stand here because I can't figure anything out, right? That's when it'll happen.
Okay.
Anything above should be obstacle. Okay. Interactive food logic.
Yeah, so that's where I probably fucked up and could get rid of the bit mask and find a much better way to do it.
I see. Yep. Likely so. But I will say, so far, I haven't seen anything like, I have not seen anything horrendous where it's like, what on earth are you doing? Which is very, very common for first environment submissions, especially if you're new to C. So this is generally all fine. Like, I bet that if you were to keep writing these and then you were to go rewrite this code in a few months, you'd probably be able to take, 50, 100 lines off of it. But it's like, this is all fine, relatively, straightforward code. So you're good. Set rewards to 0. I don't mind like magic constants like this, but if you're going to use them multiple times, I do suggest that you make them like you could just make this like an inline function or whatever, or just a
Okay.
just regular function. It doesn't even have to be inline; it's not going to matter, because otherwise you're going to change this in one place and you're going to forget to change the other one, and you're going to be really sad. So I don't really mind magic constants, but I do if you're going to do them, only use them once, right? Otherwise, like separate it and put it somewhere.
Okay.
And you have a step agent function, which is fine. You got spawn foods, you got compute obs, colors. Okay. UVs. Got the renderer. Do you know the struct initializer syntax?
No, not really.
Let me show you it. It's the one nice thing. It's like the one nice syntactic sugar thing I actually use in C.
Oh, maybe I see what you mean, but yeah, show me.
Here.
You mean to declare one the struct in like in a single line, you see?
Yeah. You can do, where is it? Yeah, like this.
Yeah, I think I've done it for agents and stuff, but
Yeah.
so, yeah, okay, yeah,
Yeah.
I see.
Okay, and where did my review go? Here it is. And then the renter. Small map, so it's fine. For larger maps, what you do is you only render the stuff that's not the background.
Okay.
But this will be just fine for these small maps. Like, this will be plenty fast. And then you have tile size, you get your UVs. Yeah, so this is very similar to our other grid-based maps. Perfect. And then you bound this here. So you have, yep, that looks all the same as you'd expect. Object actions, reward to terminals. You do my report interval trick, which is good. The reason for this, by the way, is that if you send a ton of info over multiprocessing, you will clog up the pipe and you'll slow your ems down.
Okay.
That will eventually go away though. When we do in Python 3.14, this is going to get easier because we'll be able to do a threading based vectorization. And you even did a nice perf test. Very good. You do.
I'm not ever sure that works though, because the SPS that it gets printed there is very different from the one from the dashboard. It seems very bloated up, but.
Well, how many agents do you have in here? m.num agents.
That should be
You only
by
have 8
default, I
agents.
think. The default is like 8, I think.
Yeah, it's because you only have 8 agents. So this Python loop, right? This Python loop is going to add a ton of overhead. If you were to test this with a whole bunch of ems, right? Because you can set num ems greater than 1. So if you were to set this to have like 4,000 agents or whatever, it should be way faster.
Okay.
Because you're timing this Python loop right now. And then, yep, this is boilerplate header. And then I'm sure that you got this from like my snake env or whatever, most likely.
Yeah.
You can see that like you can just build a ton of different environments with this kind of like really simple style, right? And you even have like the ability to have multiple different sized environments all like nicely laid out in memory. Quite powerful.
And I'm sure you realize like most of my code has been inspired by the square grid and snake.
Which is fine. That's exactly what you should do for initial ems. And then like that'll carry you pretty far. It's only when you start doing like fancier, not entirely tile-based stuff, right? That stuff gets harder. But I mean, to that point, right? Like neural MMO is technically a tile-based env, and it's our hardest env, right? It also has a full dynamic economy and market in it.
Yeah, that's crazy.
It's only a few hundred lines of code. Not much more code than you just wrote here.
Yeah, that's crazy when you think about it.
You can just get a lot done if you just stick to like really simple stuff and don't overcomplicate things. You can get a lot done. And you've added the puffers. Very good. Is this already in there?
Wait, I think there's the puffers. Yeah, I found them at some place sales, but the first puffer, no. The second ones, yeah, they were there, I think.
I think
can't remember where exactly though, but might have been in one environment in one folder.
Yeah,
Yeah,
right
just
here.
wait. I think I just saw a mistake in the.
Yeah. Saw a mistake.
Yeah.
Well, technically, you could get these from
Okay, here.
resources and not have to have a second copy of them, but it's 22 kilobytes. It's not a big deal.
Okay.
Yeah. So technically, you could just grab these from just resources / because it's already there. It doesn't matter.
Okay. Yes, there's a mistake in the setup.py. They're missing a comma at the end of the line. I don't know.
Huh.
I'm pretty sure I fixed that in my own, otherwise it wouldn't have worked. But
Okay.
yeah.
Cool. Well, I'll merge this and I'll fix that comma. Let me leave comments. What did we say?
I mean, remove the bit masking. Look at the struct initialization trick.
I mean, these are smaller things for you, right? The only one that's really important is make sure that add log gets called.
Yeah.
Once. If puffers don't work, otherwise we can crash suites. Say log zeros.
There's a thing though in this environment is that if you don't solve it, meaning that you deplete all the food, even if the agent keeps going around and around, you might have hundreds of steps without having any resource because basically you've just depleted everything.
That's fine as long as you actually like report that.
Yeah. Okay.
Oh, did I merge it? Oh, oops, my bad. I approved it, and there we go. Conflict, resolve conflicts. I'm going to remove, because this is just, you commented all this stuff. Remove that.
Yeah. I mean, if I would have done it like a proper PR, I wouldn't have had to push that specific file because.
Yeah, but no big deal. What'd I miss? I missed something? It's not letting me mark it as completed. Is the UI glitched?
Yeah, I saw something. Yeah, I saw. If you go back to the file, you missed one, I think. Oh, well. Yeah,
I mean, I'm gonna probably take the latest config anyways. Yeah, just need this to. Lovely.
The only thing that really matters that I added in the default.ini is the workspace name for Neptune, but other than that.
Yep, let me set up this puffer box forward. Where'd my window go? Here we are. Okay, I know what experiment that was. This I want to save. I PR this to the wrong place. Where was
I think you PR'd it to dev, but
oh, I didn't click merge apparently. Very good. Fix the setup.py real quick. Should probably name it something. Either expand the acronym or something, because people are gonna think that we've got like a, a CPR env, like, like chest
What's
compressions.
Oh,
If like
okay.
somebody chokes on something. I was like kind of confused because like I kept seeing your env and I was like, did somebody make some like chest the compression env or something? And no, it's this. It's just a silly acronym. Oh,
Okay, no, I didn't know about
you
the other
see?
one.
Yeah. That's gonna confuse the hell out of people. Let me go get the original. I want to just revert the one file, which is the config.
Okay, so yeah, I'll rename it in the future.
Yep. Okay, so just grab which config? This one. Okay. Let's see if we can train your environment.
Yeah, that would be great.
Uh-oh. That's just
Oh, that's probably the comma stuff, right?
looks like it should be.
Hmm.
Uh, huh? Why is it concatenating? It's like concatenating tower climb. Maybe something cached. Oh wait, I'm in the wrong repo, that's why. This is the right one. So we will see how fast and then how fast you have the environment running. We'll see how quickly we can make it very fast.
Let me go grab some water. I'll be back in a minute.
Compile this.
All right, I'm back.
Okay, so before I start optimizing, we're at 200K and 0.896 score.
But that's on CPU, yeah? Because that's the...
Oh, I guess so. My CPU is just faster than yours.
And you still have the 2 million steps per second. So.
It's going to take it a second to just optimize some kernels.
Okay. Oh.
Well, it'll cache them, so we won't have to wait for that again. All right, 1.4 million.
Oh, wow. That's fast.
0.3. Oh, the env is so slow, though. So slow. 45%. That is unacceptable. I'll do this instead. Is it, how many agents per env is it?
By default, like here in the config, it's 12.
12 agents per
Yeah.
env. That's a lot of agents. Let me think. 49, 340. So if I do 340 M's, well, times, was it? Yeah, 340 M's. Try this. $1.7 million steps per second training. Oh, what? No, I'm my bad. It gets faster than that, of course. Can't be that embarrassingly slow. Okay, 2.3. Now that's at least like moderately respectable. Now the score is getting lower, which I assume is the bad thing.
Yeah.
Out of here, bot. Yeah, it's like several bots a day on stupid Twitch.
Yeah, so looking at the score and the move, it probably means that it already depleted the resource entirely. And so basically it's just, I don't know, running around in circles.
I mean, they will just deplete the resources unless you, yeah, that's going to be a tricky thing to figure out. Now, we can
Yeah.
at the very least, I think this is going to be funny. We can just do this. Oops. Hi, learn about project today with the iceberg video. Nice and looks active. Welcome. What env are you looking at? This is a newly merged in environment by M1000, who I'm on here with on the Discord. It is a collective resource collection problem. Is that a good description? Tragedy of the commons kind of thing? Yeah.
Yeah, it's exactly that. You need to just balance the harvesting speed, basically.
So I'm just getting this nicely integrated. And if you're looking to get involved with all this stuff, discord.gg/puffer. Got a whole bunch of folks in there building M's and contributing to research. The score is no longer completely messed up, actually, which is kind of funny. I don't know. Huh.
So there's still a very, very slow probability of respawning a food in the middle of nowhere. So I don't remember exactly the probability, but it might be like once in 100,000 steps or something.
Oh, that's really
And
low.
yeah, so that was just fine on my CPU, but since we're only running like 135 million steps, probably.
Yeah, my guess is that's going to be an issue. I see the problem. You're trying to get him to learn. It's just kind of tough to get him to learn to not take the food when it's like 100,000 or whatever delay if they do.
Yeah.
We can see what these guys do. My guess is that they will have forgotten how to do anything though, because they won't have there won't have been anything for them to do for a while.
Yeah, the thing I might think about it was just adding the death system to it. So basically, they have health, and if they don't eat, they just die and gets a very big negative reward. So that would just incentivize them to maybe keep eating at some rate, but not necessarily harvesting everything for themselves. I don't know.
You definitely can play with it. It's you've gotten yourself into a problem with some tricky dynamics. You can see the scores all the way down here. Now let's see if I just.
Oh yeah, wait, you're actually answering one of the questions I had on Discord. So, how to catch up on the latest experiment? So.
How to catch up on the latest experiments?
Yeah, so once you've been training or sweeping experiments, I wanted to find back.
Yeah,
I wanted to find back one experiment from Neptune or something.
So these guys don't look very smart. I mean, they're kind of doing some stuff, but my guess is they're not that smart because they haven't had much to do in a while.
Yeah.
I bet you that they'll be like noticeably smarter if. It's actually weird that they're not even eating this food. I guess they probably just ate all of this food in the original. Ironically, if we do this, it'll probably be better. I'm glad people actually are finding the project through that iceberg video because it didn't get very many views and it was a lot of work. You know, actually, one thing we could do is if I just do like this, okay, and I just put this on Neptune. Just put this on Neptune. You don't have access?
Yeah, so that's you need to replace the workspace with yours in the config file now, right? That's probably it.
You're doing great. You can bring more audience from Twitter. I mean, Twitter's my main thing, so the only thing is I can't tell how many people are actually ever watching on X at any given time. It only tells you the total view count. So I don't know. They gotta fix that.
I named it workspace. I'm not sure if it's on the default since
okay. Yeah, because I
erase my
updated.
change.
Yeah,
But it's probably on my cpr.inify, which is being overwritten basically. I would assume.
Yeah, so what we'll do then is we will.
Yeah, it's here.
You have score in here, so you don't need this because you already have the same metric, right? Which is score. Or
Yeah. I used to have episode return. I just changed it when I saw one of your streams talking about.
yeah, just having score for everything is nice.
Yeah, okay. So now I just have it for everything. Yeah.
So what I'll do is I'll just put this into config default. We'll just do this, right?
Yeah. I wonder if the name is not the name of your workspace though. So for
it's
you, it
Puffer
would be
AI.
Puffer. Yeah.
It's funny how we had a bunch of folks on Twitch and they left, and now we have some folks on YouTube. Okay, so what I wanted to do here is I wanted to see how moves changes over time. It's just easy thing we can do, right? So we do. Yeah, so this is just going up over time. So my guess is they just eat all the food.
Yeah, I mean, I had a system before where there were no depletion, which is obviously a completely different environment, but you could see that the moves was going up and then down after it learned correctly the thing. But now with depletion,
Yeah. So you should probably just do some sanity stuff, right? Like have some sanity settings for the environment so that you can actually get the learn curves and stuff before you try to go solve the harder problems. That would be
okay.
my advice. I left this like this because usually the defaults are pretty good. You know, you can always put stuff back if you want to. Like the defaults end up being pretty good at this point. Yeah, the need to tune like every individual hyperparameter just to get it to do something is very much fixed by the new optimizer changes, which is really exciting. Let's see, I did 340 M's for you. You can see your M's at 1%, 1% of the time, so that's really good.
Okay.
It's nice and fast training. I think if we do this, if we do device equals CPU, tune.
I mean, I wonder if I could just make this the grid a bit bigger with the same number of agents. So, you know, the time the agents learn to harvest the food in their own corner, the food would have just grow a lot much more in the rest of the environment.
Could be.
Then, yeah.
Cool. And then, yeah, once you're ready and we have like a cool policy that does something, we will add it to the website, and yeah, it'll be fun.
Yeah, that sounds cool, man.
I mean, it's pretty nice how easy it is to just like stick everything on here. We're missing a few of them. We got to put Blastar on here. Obviously, Impulse Force is going to get up here at some point. Spencer's got his port of GPU drive. So, fair few new M's. That makes 4 now. Oh, and then Bet also did like a quick cartwheel implementation. So 5 new M's will be added to this.
And that's great.
Cool. Any other questions for me on this?
Yeah, one last one I can think about is once you have once you start a big sweep on Neptune, and you find like one set of hyperparameters are great or something, and you want to find back the model, the .pt file, back on your experiments, how do you?
I don't know if I have that set up at the moment, honestly. But the thing is, the experiments are like, at least when I'm running them on GPU, the experiments are so fast that I just go grab the hyperparameters and like.
And you run them again.
Yeah, but then the thing is, like, I want to do that anyways because I want to make sure that the experiment replicates, right? So.
Okay.
That's usually what I do.
Yeah.
Well, the other thing is, when you say how do you find back the originals, like if it's on your same machine, which is I guess it is because you have one machine.
Yep.
I think, does it tell you the name? It gives you this ID. I don't know if it tells you what this ID maps to though. I think I've done stuff. Well, if you're running a sweep, the experiments are going to be short enough that it's probably not going to matter. Like if I'm running one experiment, I'll just, ls,
Okay.
and then that's like the most recent ones. Very unique idea on the website. Thank you. Yeah, the website's fun. It took a little bit of work. Like the neural net's running live in your browser is this C file right here. We have like a version of the torch layers that exactly matches torch, but is just in pure C, so we can compile it to WebAssembly. This was a fun project to put together. Cool. Anything else, or should I ping Omid for optimizer shenanigans?
No, everything is good. Thanks a lot, man. It really helped.
Okay, cool. Well, thank you for the contribution. Let me know when you have like a policy that you think, okay, we have something that trains and kind of does something that you can see is cool on the environment, and then I will show you how we port policies to C. It's pretty simple, especially for the default policy, and yeah, we'll get it on the website. We'll get you on the contributors list and everything. And yeah, thank you for the N. I hope you build some more M's and keep staying involved with Puffer because we got lots of fun research around here.
Yeah, same. Thank you. Good luck.
Thank you. Bye.
Bye.
That was fun. Always love when we have random new environment PRs. This one looks pretty cool, especially for some multi-agent research as well. I'm going to take... Well, let me just ping Omid. Okay, I've pinged him, and he'll probably be over in a minute. And we'll do some optimizer stuff, and we'll see where we go from there. Be right back. Okay, we're back. Omid should be here in a second, and we can look at a bit of optimizer stuff. See where he is. Is it, I think it's 10 years per billion? No, it's 20 years per billion. I remember I did the math for this a while ago. Divide by 365 days, divide by 15 years. Oh wait, no, it is. Divide by 0.6. I think it's 10 years. 10 years of games. Yeah, there it is. 10 years of games. This guy go. They even have voice channels? I guess they do. Alright. Let's see what experiments we have. I think these are... I mean, we have a number of good candidates here. We can take a look at, we can definitely take a look at some analysis from this. Oh, sweet progress is going to be a little tricky because we don't have a score metric. Let me think about that. I could just make a new dashboard real quick.
Hello?
Hey, how's it going, man?
All right, sorry about that. I don't know why it wasn't.
You're good. We're on stream. Is that chill?
Yeah, it's chill.
All right.
Thanks for checking.
I just like to tell people. I stream
Yes,
all my
sir.
dev by default, so.
Yeah, but might as well just check. So this it looks like PSGD is doing well.
Well, at least on the initial test it is, and I have some plots that I'm just adding right now from, I think, 12, 15 billion steps worth of experiments.
Okay, sweet.
So, it's about, I think it's about 20 years of games per billion steps. That's how the
I
math works
wonder
out.
how it like fares against like an IRL, you know?
Well, if I'm going to count, if I get to count like 3.3 billion years worth of evolution, then sure. I
Yeah.
should be able to count that in my x-axis.
Yeah, I mean, like, would it be as good as a pro at this game, you think?
Oh no, not even close. They're pretty dumb.
I see.
Like, yeah, no, this is a hard to learn benchmark.
Okay.
Can I sweep for a joint metric like A plus B, or do I need to create an A plus B metric in the env? You need to create an A plus B metric in the env, Spencer. So I have right here, I'm looking at the pre-con learning rate and the learning rate. I'm going to see if like we can figure out. It's a little weird. It actually increased pre-con learning rate on the run I was looking at. That was good. It didn't drop
Yeah,
it.
so I think the thing that helped was the what is it called? Increase in momentum.
Momentum?
Right? That's what you had said,
Oh.
right? You had said
Well, what controls momentum?
B1.
Oh, yeah, let's go look at beta 1 then. I don't know if you have stream open because I'm making all these
Yeah,
graphs.
I do.
All right, so here we have. So the really high point is the muon baseline, but that's been run for close to 100 billion steps by now.
Yeah.
I can take this one off real quick.
Would like to see PSGD catch up to it in real time.
Well, these runs are going for 500 million steps only.
I see.
That's pretty tough to do. So, I mean,
Yeah.
you see over here, we've got betas. I mean, I don't see, yeah, you'd see it like didn't work well on these low betas, so it went to this high beta, and it looks like there is a good run at 0.9 actually here. Oh, no, wait, this is the other really long run. Hang on. Yeah, this is the other really long run. Where is it? 27 right here. I'll just do this.
I need to move away from weights and biases.
I said on stream, like, yeah, I've been using Neptune a bunch lately. I think it's a lot nicer now. And I think I got a DM from the CTO I still have to answer of weights and biases. So I don't know if he was watching the stream or one of the engineers was watching stream, but it's funny how that stuff happens.
Yeah, I mean, I would definitely enjoy they're telling me I need to pay now, and I'm like, leave me alone. I'm not gonna pay
See,
for
the
your
thing is,
product.
I don't even mind, like, I don't mind paying, but if you're going to try to make me have all of my open source users pay, then that's not going to fly.
Yeah, that's fair. That's fair.
That's the
All
big
right,
issue.
so it's saying like around 0.95
Yeah.
is okay. And then how do we okay, and it's really weird how the learning rate, so train learning rate, we have one on the train learning rate that is like way higher that did well.
They don't have Logit as an access option for beta, but you get the idea.
Yeah.
So
And
it
is
looks
this
like
with
somewhere
Mars
in here.
turned on?
No, I don't believe so.
Okay.
I didn't see a big difference from Mars though.
Wait, the environment what's the y-axis? Sorry?
Mincom prof.
Yeah.
So this is, you can level up combat. You can level up your
Okay.
professions. Mincom prof is the minimum of your profession level and your combat level at the time that you die.
So
So in order
to
to get
somebody who
two,
doesn't understand games is
in order to
yeah.
get two, in order to get from 1 to 2, 1 is the default, right? In order to get to 2, you have to go find an enemy that you can kill it, pick up the tool that it drops, and then go equip the tool and harvest something that you can harvest with it.
I see. Level up.
Yes.
The higher is better. Okay, makes
Higher is
sense.
better. The
And
max is
so
like
it's
20.
telling me that okay, having too high of a learning rate, not good. Somewhere around 0.01.
The
A little bit less
muon
than that.
learning rate, the optimal muon learning rate that we were using for a lot of stuff, not for neural MMO, but for all the other M's, was like 0.025. It was quite large.
Yeah, so I don't want to say this, but if you also do PSGD incorrectly, you can have a higher learning rate.
If you do PSGD incorrectly.
Yeah, so if you run the momentum in a specific way, it can change the. So basically, what we did for this is equivalent to Atom, right, in its style, because it's doing gradient based whitening, right, which is what muon should be doing as well. And somewhere, I think they like to tout that they can use a higher learning rate, but that doesn't really mean anything. It's just
Well, yeah, the only thing it means is like, does your thing work faster than other algorithm, right? It's like they can be differently scaled.
exactly. And so if you do the proper scaling, this is the number you should have for the learning rate, which is nice, because what would be nice is if we could see this actually for Atom and see how the learning rate and betas like correlate with each other between optimizers.
I have it for muon. I don't have it for Atom.
Yeah. Okay. And preconditioner learning rate, not too high, not
Actually,
too
I might have it for
low.
Atom. Hang on, I do have it for Atom. Here is 200 experiments worth of Atom. Yeah, so we have 200 experiments worth of Atom. See if I can find the betas. This is sample. Yeah, so here are your Atom params. And what I do usually is I limit it to the good runs. So I say, okay, let's say a minute. Minute's a good budget for breakout. So we do cost, cost. So now these are the experiments we're looking at. And we can see.
Okay, so beta 1 would be, yeah, so it's around that 0.96.
Oops. Hang on. Just make sure I'm not covering it. There. So beta 1 for muon is about the same. It goes from about 0.9
For Atom.
0.96, yeah, for Atom. 0.96 to 0.995. So it just seems that it needs to be higher than the default of 0.9.
Okay.
Right? And then beta 2, I think the default's 0.999, which seems fine.
Yeah.
Because anything in there is fine. And then the epsilon. Well, this one's interesting because I remember when I did this with muon, it went epsilon all the way to the bottom, but I guess muon doesn't have an epsilon. I don't know. So here's an epsilon.
So muon's epsilon is just, so muon can only handle 2-dimensional weights. So for 1-dimensional weights, it just defaults to Atom.
Oh, okay. So anyways, there's an epsilon here, and it seems pretty high. I think the muon one was a higher, but whatever. Yeah, it set some weird epsilon.
One thing with muon is they like to set, and it's true in general, right? If you have a multi-layered kind of neural network, they like to set the learning rates of the they have both an Atom learning rate and a muon learning rate. So like different portions of the network should be receiving different learning rates, which would be
Isn't it just the biases?
a lot.
We don't have any like NN embedding layers.
Yeah, so even for like if you look at Peller's Sci-Fi 10 speedrun, he will use different learning rates for different layers, just in general.
Well, CFAR I trust less than GPT. CFAR is like a freaking 3-second optimized run at this point.
I think it's like two point something, but yeah.
I was looking at the Nano GPT runs as of late. I don't know if they use it there.
They do.
But then like they have embedding layers though.
They do. Oh shit, I'm getting a call, give me a sec.
Emmy's here. Hello.
Yeah.
How's it going?
Oh, good.
Many experiments have been run.
Yeah, I was seeing.
So far, it seems like we've got pretty clear spikes. Beta of like 0.96. Learning rate at, what's this, 0.0025. And then precon at 0.15.
0.15.
Yeah, it increased it.
Muon doesn't have the plasticity issue that PSG is having right now, right?
Well, I don't know if there was a plasticity issue or if it was just a hyperparam issue. Right.
Yeah.
It's a little tricky. Like with everything else in Puffer, I can just be like, oh yeah, here, 200 runs, that'll take a couple hours. This one, it's like neural MMO3 is actually kind of hard. So each run's 500 million steps. So it takes a little longer. But if I get the graphs, right, here are graphs. I can get you the baseline for this. So this is the baseline. This is Muon. So Muon does this. And if I go like this, we have PSGD.
Where are you showing that? You're showing on chat, right?
On the stream.
Oh, I don't see a screen though.
X, YouTube, Twitch.
Oh. So am I being streamed on Twitch right now?
Yeah, I told Omid when he hopped in. But yeah, my dev is live by default.
That's fine. That's okay.
Yeah, my bad. I see you kind of just hopped in, and I was like, oh, you're here.
Yeah, I got the, yeah. Okay, let me see. Let me see.
Yeah.
J Suarez on Twitter.
Yeah.
Where is the stream? Okay.
Yeah, I stream like a good 40, 60 hours a week, depending.
Well, Muon is pretty cool. Wait, what is the gray one? The green, white one?
At the top, this is PSGD. These are all
Wow.
PSGD. But the thing is, like, so I had, before I tuned this, I was doing this. Let's see. Let me see if I can find either runs. Oops. So this was me trying to tune PSGD manually.
Uh-huh.
And like it would be higher for a bit, but then it would intersect.
It would stall, right?
Yeah, it would stall. And let's see, did I do more of this? Yes, technically we have these as well.
That is just a lot of sweep, right? You didn't change anything else.
No, just there's another sweep because I had to fix some bugs in the way that it was sweeping.
Oh.
Maybe I got the params better or something. But yeah, the latest one here, the latest sweep that I have that's the good one, where I'm actually getting the results, is this one. You can see that some of them are still below. Like some of these don't learn. But now we actually do have results, and they don't seem to stall anymore. So I'd assume it's like one of these parameters that was just bad. Because like this is not random search, right? This is protein. So either it was the preconditioning or it was the learning rate or like beta. One of these was like causing it to stall.
I mean, were you using unconstrained beta search, or are you constraining it to some like specific range?
It's constrained. The way it's like it's a Pareto optimized genetic search, and it's like a genetic search in log space of some of the parameters or logit space depending.
Awesome.
What's PSGD? Ask these guys. It's an optimizer.
There's an optimizer, and is being actively.
Some fancy optimizer. I don't actually know how it works yet.
Is being actively advertised by Omid.
It's not parallel SGD. What does it stand for?
Preconditions.
Preconditioned.
Stochastic gradient.
Okay, preconditioned stochastic gradient descent. There you go.
It's like a very esoteric optimizer, to be honest with you. Like, it requires a lot of dark knowledge to understand, I suppose.
Unless you run
This is
exhaustive
what a lot of people told
experiments.
me. It takes a lot of time to understand it, but it really works.
So I did run one other experiment that I thought was kind of cool. So
yeah,
when I tried to run the breakout parameters or whatever, like the defaults worked on breakout, but they didn't work on neural MMO. But then I took like the precondition LR, like 0.15. I took the beta and I took the learning rate, and I tried those on breakout. So I tried to transfer from the complicated M to the simple M, and that worked.
Oh, interesting.
So I think actually the defaults just might not be that good for RL in general.
Wait, just to be clear, the way you the rewards, they're sparse, right? And they happen like every, and then for the complex M, the rewards, are they delayed? How does that like? How's the difference?
Well, the complex M is right here. Not that. That's breakout.
I don't see. Are you sharing? Then for the complex M, the rewards, are they delayed? Sorry, I had to mute it.
Yeah.
Are they on? I can't see it. Okay, here it is.
The stream takes a second to catch up. So this is neural MMO 3. You can see if it kills an enemy, it'll get a reward. It can't kill this enemy. This enemy is level 6. It is too strong.
This is the hard one, right?
Yeah, this is a hard end. So if I just unlock the camera, like it could go kill this enemy over here. It could not kill this one. It's got to go find something it can kill. And if I just take control of this thing, now I'm controlling this bot right now. It's chasing me. Okay, well I gotta die so I can get a full health bar. I'll show you what will get reward. So in order to get reward in this end, I gotta go find an enemy that I can kill. You can see it takes a while. I gotta like look at their levels. That one's too strong. This is a level 1, perfect. I attack it. I go get this tool. I equip this tool. So I got a reward for killing the enemy. And now if I go pick up an item, I'll get a reward. So I'll get a reward for that. This is a consumable. I can use it to heal. And then I harvested an item, but I got virtually just one shot by that thing. So yeah, now the other one killed me with a bow. But there you go. So that's Neural MMO. Big map. Lots of different resources, lots of enemies, lots of agents.
Wow.
And, yeah. This is the small version of the map that we use for the web version. And also there's an economy. You can buy and sell stuff. So like if I try to buy something, like there's this menu. Other agents have to be selling stuff on the market. But
wow.
Yeah.
Sorry, I got
it's a
a
fancy end. What issue is the PSGD supposed to solve? Raw eval or something else? It's supposed to be a better optimizer. Omade can advertise PSGD to you in the Discord, I'm sure. But yeah, this is Neural
happy
MMO.
to.
And if I just hit Control, the policy will take back over, and now NeuralNet is playing it live in your browser. Unlock the can, relock the camera. See, so right now you can see there, it went and it got a tool, but it got too close to that agent with a bow. And it doesn't realize that it can get hit from range.
Not maintain the same technical fight. They show that it
It's got some jukes, though. So this is the end. So you can see this is as far as RLMs that are typically used in research go. This is not exactly easy.
Yeah, I mean, I guess like if the rewards are like less frequent in some of the M's,
Yeah.
and on the others they are. I think that's gonna be like that's gonna make a lot of difference on the outcome.
It's hugely
was able to
difficult.
transfer.
Every other env and puffer, like you can at least get some reasonable performance on, like out of the box, and like in a couple minutes of training.
No, I mean like Muon transfers. Muon parameters if you transfer them from the harder environment to the.
I didn't do
simpler-
that one.
simpler-
I did. I haven't tried that yet because I'd have to run a full hyperparam sweep on Muon. I haven't done that. So this hyperparam here, this is the learning rate and atom params from tuned on breakout, and then the rest of the params from like a much earlier atom sweep. So Muon is not optimized here at all. If we wanted to do a head-to-head comparison, we would have to do that. We'd have to, run both sweeps.
I see. Yeah, I think that makes sense. Why you'd have to like sweep the precondition a lot. I really don't know how PhD is good, but I don't know how it works. But I mean, I suppose there's a lot of things that you have to be tuning for PhD.
Well, I didn't need to on any of the other ends. It beat Muon out of the box on most of them.
How were the rewards? Were they sparse or like very very close? Do they happen close or?
We have
it's a mix.
It's a mix. It depends on the env, right? Like you can just click around on all of these different envs. Like we've got Atari games that are fast, right? We've got this like snake. Obviously, you're gonna get a reward when you get food, right? So it's like every few steps. There's sparser stuff like this is.
Simpler envs, right?
What's that?
Those are the simpler envs.
Yeah, these are simpler envs.
Yeah, the simpler envs you get rewards quickly.
Yeah. Well, there's a little bit of complexity because this is not exactly simple because this is also multi-agent competitive self-play, right? Like you kind of have to be aware of what all the other snakes are doing.
I see.
But then yeah, we've got board games. There's like Connect 4 in here. There's Robot Warehouse. This one's fun. You go pick up the crates, you bring them back. This one's pretty mesmerizing to watch because they'll just like do this on repeat.
Interesting. Yeah, I mean, the only hypothesis that I had was like it's just that some of the harder M's they have just like very sparse rewards.
This one is very sparse. This one is very sparse, but it's very easy.
Oh, interesting.
Because this is 60 FPS. Right?
MPSGD beat that, right?
What's that?
MPSGD beat that.
Oh yeah, you train this in like less than a minute.
Wow.
Our speedrun record on this environment is 30 seconds, 31 seconds.
Wow.
This is a much older policy.
The CFAR runs that Keter has.
Well, that's using more hardware. This is one GPU.
Oh no, the CFAR runs, they only use one GPU.
They do one GPU in like 3 or 2 seconds or whatever?
Yeah.
That's kind of crazy.
Yeah. He added Neon into it recently also.
That's crazy.
Which is pretty cool.
So, I mean, you can see, like, this is a reasonable enough policy. We've got Pong. What else do we have that's fun? There's Go in here.
This is the AI playing it, right? Or is that you?
This is the AI playing. It's not very good. Because, well, the opponent isn't very good either is the thing. But it can win. You can train it in a few minutes to beat, like, the whatever the scripted opponent we have is. It's very hard to make, like, a good scripted opponent for Go.
Cool. Is Obi gone? Is he gonna join?
Is what? I don't know. I don't know if he's still here. He said I had to hop off VC, but then he didn't say anything. Oh yeah, this one's cool. This is MOBA. This is like miniature version of Dota.
I've never played Dota before. Seems interesting.
It's a 5v5 team game.
Is it multiplayer?
Yeah, it's 5 versus 5.
And these agents they're playing multiplayer, right?
Yeah. Well, they're playing. The blue team is controlled by the AI, and the red team opponent is scripted.
Wow.
Now the scripted bots aren't very good, right? Which is why they're pretty easy to beat. Yeah.
I wish I did Muon for my optimizers for my models before for my RL models.
Yeah.
Wait a moment.
Well, I mean, all these demos were trained with Atom and like just hyperparam sweeps, right? Those are the ones on the website. So these are the M's we have at the moment. We have a few more M's in development as well.
M's like what?
There's Impulse Wars. Insane. Probably this is one of the... If you just look in the dev chat. Okay, yeah, this is GPU drive. Well, a port of GPU drive to CPU. Spencer's been working on this. It's pretty cool.
What about you remember there was like a racing car thing?
Isn't this it?
There was something more realistic than this, I remember.
GPU drive?
Mm-hmm.
This is a port of GPU drive to PufferLib. We're working on a port. Yeah, so it's the same thing. It's just we haven't made the renderer as fancy yet. But yeah, it'll be the same dynamics as this, and it's going to run way faster. That's a collab with NYU. And
oh, you're collabing with NYU?
Yeah, that's a collab with Eugene's group. And then this is Impulse Wars. This one's really cool. So this is Captain's environment. I helped write the renderer for it, but the actual logic is his project. This is a top-down physics shooter. So this is going to be another like pretty cool M for us to use.
Yeah, seems cool.
I mean, the thing is, like, I honestly think that, like, at least neural MMO, some of these, neural MMO especially, probably impulse wars as well, a lot of these are actually harder optimization problems than a lot of RL in industry. So it's kind of like, okay, if we solve all of these out of the box, probably we solve your problem too. That's the idea. Yeah, it doesn't look like it's finding anything much better than these. I'll let it keep running for, I'll let it keep running until tonight, but it looks like about this curve. This is about what we're gonna get. So like 1.9, 1.8, whatever. Oh yeah, where's the dashboard? Yeah, so just disable this one. Beta of 0.96. Learning rate of, there's pre-con learning rate of 0.15. And then learning rate of 0025. This seems like the good setting. I wonder if there is something to beta being too low, like the default beta being too low. But I think this is the only parameter I didn't play with. I didn't play with
this. Is that from Yon?
What's that?
Is that from Yon?
No, this is the beta for PSGD.
Okay.
Well, actually, it looks to me like if you look at this, you need the learning rate to be 005. Hang on. Pre-con learning rate. I mean, this still kind of trains. You even have like a good point all the way out here. With the pre-con learning rate at 0.3, you still have a decent point. It really just seems like 0.1 is just too low.
Do you use 0.1 for okay? Wait, didn't Lucas say to make a higher to make a lower?
Yeah, he said to lower. He said lower the pre-con learning rate, but the sweep says to make it higher.
Wow. So about something around 0.15, right?
Mm-hmm.
That's the best you got.
So far, yeah. And I mean, like, way higher, it still works, you see? At 0.3.
So, I mean, is it telling you that it's uncorrelated or it doesn't make sense?
No, it's saying, look, I don't have any good runs when it's too low. I mean, it could be that if I keep running more experiments, right? You don't know until you have enough experiments, right? But so far, we don't have any really, like, none of the good experiments come from it being way lower over here.
Actually, there's only one bad run when it's the preconditioner is like way too high, but they are like 1, 2, 3, 4, 5, 6, 7, 8 ones.
And we're sweeping a lot of parameters as well, right? Like we're sweeping a lot of hyperparameters, so it's pretty easy to get bad settings for the other hyperparams that'll screw you up.
Cool.
Yeah, this doesn't look uncorrelated to me. Could be. But beta definitely here. Like, look, I don't have any good runs with 0.9. I guess we get 1.4 is okay. But we, like, all these runs, we start getting way more good runs at higher.
Wait, I mean,
and this is consistent with my Muon sweep as well.
When I asked for if the beta parameter was constrained, this was because of that. I don't think this is so interesting. I mean, like.
Well, you can get the full. I mean, we are sweeping a lot of different things in this, right? The protein is pretty good.
So I mean, even 1.0 beta. Okay, are you sweeping 1.0 or like 0.9999 like for beta? The top right.
Top right. There's nothing up here.
There for beta like the bottom right, the
This?
closer there.
Or this. This
Yeah.
This is just 0.991.
So 0.95 is the one that's working for you.
Yeah, pretty much everything around 0.95, 0.96. Like these all do reasonable things. 0.96 seems to be the best one so far.
You should be sweeping Muon as well. I think that would be very interesting.
Well, we'll do both, but I want to at least get like. What I would like to do is I'd like to see. I guess I kind of have finished with this. Well, I'll let it keep running until after dinner at least, but I'm gonna take these parameters and then go run them on all of the other environments to see whether the same PSGD params work on everything in Puffer.
Oh, okay. Because you're doing this because you had an issue first when you tried the simpler end, it worked, and those HPs did not transfer. So now you want to find the best.
To be fair, in Muon it didn't. I had this problem in Muon a little bit. But Muon was generally pretty good. The thing is, these were never tuned on anything, right? This PSGD params. I guess technically I could just go tune PSGD on Breakout and see what that does, right? See if it finds the same thing. Because this does pretty well on Breakout.
Neptune?
What?
Do you use Neptune instead of 1B?
We provide support for both, but yeah, I do.
Is there a specific reason you like Neptune better than 1B?
It has a faster UI. It shows more points. It's way easier to download your data for offline analysis. You just can download the whole thing in one table. And these dashboards are really nice to set up because you can apply the same view to whole different groups of experiments very easily.
I see. I think I might as well just move to Neptune. 1B has crashed. 1B has been crashing a lot these last couple of days. It crashed at least once an hour. Once when I'm looking at the logs. It's been pretty shit.
Yeah, web interfaces are just like. I don't even want to see the code behind any of these web interfaces. There's probably such a big, obnoxious, heavy stack.
I mean, there are no clients. They don't have any clients. I don't know.
Who doesn't?
I mean, they don't have any app clients. I think they would make a worse app client than a web client. The people behind this. So it's better that they stuck on the web.
I don't know. I mean, you can do either way. That's the funny thing with it, right? Like, if I were going to do this, probably I'd be ridiculous about it, and I would just go implement the whole thing with Raylib. So you just run the C code on the web or run the C code locally.
Their backend is probably XC or something.
Not the rendering.
Yeah. No, I don't know if the rendering is the thing that's crashing it. I think it's just the software is bloated. Yeah, I think I'm gonna switch to Neptune. I think this.
It's a good thing to try. To the credit of Wanbi, I think somebody asked me about this the other day on stream, and then the Wanbi CTO DM'd me like, "Hey, I heard you're having some issues, so I don't know. Maybe I'll give him some feedback. Maybe they'll find ways to fix it, but it's really tough to unbloat software, right?"
Yeah, the Neptune one. Do they do they now have like the dark mode setting?
No, they don't. That's the one thing that everyone asked for that they haven't done.
Okay, do they have? Is it real time when you're looking at numbers? Do they pop up very quickly when the model logs, or is that still like it's like there's latency?
No, there's still latency when the model logs.
Shit.
Yeah.
I mean, like latency not from the model side. If the model submitted the results to Neptune, does it show you on the website very quickly, or like one takes like one had like 20-second or something?
Yeah, it's about the
latency,
same
right?
here. It still has like 20-second latency.
Shit.
Look,
no reason for me to switch
I'm
then.
busy solving reinforcement learning. I cannot go pivot to make a dashboard visualization company.
Yeah,
Right.
yeah. Maybe someone will make us a better visualization tool. For the stream watchers.
Yeah.
You can do it. I believe in you.
I mean, I don't doubt that I could, but I can do a lot of things, but I can't do everything at the same time.
Oh no! I wasn't talking to you. I was talking to stream listeners. To the people listening to the stream.
There are a couple people. It's not much at the moment. Like before, we had like we had a decent few folks on Twitch earlier, and then some on YouTube. It depends on what I'm talking
Yeah,
about and what we're doing.
I remember one time we had like 1,000 streamers. That I remember.
That's 1,000 total views with X, I think. It's never 1,000 concurrent. It's like 10 at most. It's small.
Ah.
No, you don't just. What do you think? Do you think there are 1,000 concurrent viewers watching like niche esoteric RL research? No.
I mean, maybe, who knows?
But
I am watching.
Yeah. Well, I mean,
research.
I will say though, like, it is really good for for getting new people interested in Puffer. It attracts new contributors. We did the code review for a new env today live on the stream, and like PR'd a new env into Puffer. A lot of that type of stuff.
Pretty cool. Well, I was hoping to wait till Omi joins you guys again.
I don't know where he went. I think he just dipped.
Oh shit.
Oh, Aaron's here. Hey, Aaron. Did I miss messages
Hello.
from you?
No, things seem like they're a little bit more working now.
Awesome.
So I was thinking that the next good thing to do would be to take this all and get it running a new sweeps.
Awesome. Yeah, we can definitely do that. We're currently testing new optimizers.
Nice.
I will show you the current neural MMO. So previous.
I'm on my phone, so I won't be able to see it.
Okay, yeah, shoot. Yeah, because we're also live for reference.
No worries.
Where's this thing? Where's this thing gone? Oh yeah, here. So, I mean, we've got some pretty nice results. The previous best with Muon, which is by far better than the previous Atom baseline. At 1 billion steps.
I gotta hop, guys.
See
Have
ya.
a good day.
What's up?
Hey. So the previous best was, what's this value? Like 1.1 or like 1.15 at 1 billion steps. And
yeah.
We're now at 1.95 at 1 billion steps. It's the best result.
Oh, hell yeah.
And so Muon, I think it gets to 4 or so total after 100 billion steps. And it got to only 2.5 after 100 billion steps with Atom. So we're already closing on 2 in 1 billion steps, it looks like. So that's pretty cool.
Oh yeah.
I don't actually know why these are running for 1 billion steps, because I thought I had set it for 500 million, but I guess they're running for 1 billion.
So you're saying PSGD is closing in on Muon, or?
Well, I mean, did you have the stream open? You've seen the graphs, right?
Yeah.
it's way above muon for the first billion steps. I haven't run the long experiment yet to see. What I was going to do, because each of these takes like half an hour or whatever, I was going to wait until after dinner, see if, anything has changed, and then just load up the best preconditioned parameters into a much longer run.
Would you be down to add like weight decay and stuff like that, or is that going to be too much of a headache to try to add in?
Well, I can add that immediately. It's just that if I want to know how much to add, like, I have to run a new sweep, right?
Yeah.
So because the thing is, I haven't actually seen much use of weight decay in RL at all. So what I was going to do is I was going to just optimize these params, and then I was just going to do like a sweep over only weight decay. So you just have one variable param, just to see if it does anything. And if we get signs of life, then we can rerun a full sweep with weight decay.
I see.
Where weight decay is meaning what in this context?
L2.
No, like what weights are decaying?
Like L2 regularization added onto the policy weights.
Okay, you said L2. I didn't hear the L.
Yeah. Weight decay is L2.
I've seen it. Like, I've definitely seen regularization applied to RL. Yeah.
Did it do anything?
Yeah, Evan's also
it was pretty necessary.
Yeah.
Go ahead.
Go ahead.
It was pretty necessary for AlphaGo. But, you also had the additional complexity of search.
And shitty old methods.
Yeah, so Evan had said on PPO he saw even a little bit of weight decay, like E1 e to the -4 was helping quite a bit.
Well, we'll be able to sweep it on this because I got a much harder task here to throw it at than he has with Atari, unless he's got internal ends.
Yeah, I have no idea.
I mean, the cool thing about this, right, is if I get signs of life on this, I can just throw it at everything and we can see if there's a difference.
I hear you.
The reason I'm doing this long sweep right now is I was having difficulty getting like tuning on breakout and having it transferred to neural MMO. It did, like, every single other one worked, right? But getting it to transfer to neural MMO didn't. Actually, I think I'm gonna start just a local run with just these preconditioned params to see if this does anything. That'll be a good idea. I don't think I've done that. My parameters.
Anyway, I just wanted to pop in. Joseph, we should take some time tomorrow or Friday, I think.
Integrate stuff tomorrow?
Yeah.
All right, I will attempt to have optimization for RL solved by tomorrow.
Sounds good.
See you, Aaron.
I've got some other stuff to run, so I'll see you later.
See ya. Cool. Here, I'm gonna start a neural MMO 3 run, just locally. See if there's anything that I need to take into account here. I don't think so. It's got like 2 M's and stuff, which is kind of gross. I don't know why it did this. Oh, it probably did this because my sample efficiency, right? Let me go check that real quick before I start this. That did just occur to me. Yeah, it's gonna do that. Okay, so let me Here's the x-axis from step to time.
You can't stream on Discord as well, can you?
I can. Here. I have a 4090 locally. It should be able to do some stuff, don't you think? Maybe when I start running the maybe when I also start running this experiment, it'll explode or something, but
maybe.
Discord's pretty good, Jason. I don't know why this is set to 2 update epochs is the only thing. I do not like that. But I'm gonna try to run the I'm just gonna try to run the LR precondition stuff and we're gonna see.
What do you mean the LR precondition? Like the probability?
I'm gonna run with the correct settings.
I see. I'm trying to connect my laptop to my monitor, and it was working like 10 minutes ago, and now it's not, and it's just like so frustrating.
Tech issues abound. Okay, so this will be default parameters, except the swept, learning rate, precon, atom beta, all that. And I think this should train pretty quick. Let's see how long we're supposed to have to wait to see some activity. It's supposed to take off within like 100 mil or so. We're supposed to start seeing something.
Nice.
But it's kind of funny because within 100 mil, most of the other ends are solved. Yeah, there's so many other M's and things I need to do. It's like, it's a lot. There it goes. So that's already starting to optimize return. Though it's not optimizing
Nice.
the mincom prof is the main metric. I should probably just call it score so people know that score go up is good. The other cool thing I saw from the Muon baseline was there was market use, even from the Muon baseline.
What do you mean market use?
Agents were buying and selling stuff.
Oh, interesting.
It's kind of tricky to learn.
Is that not occurring with PSGD?
Well, we haven't run it long enough. That takes a while to learn.
I see. Was that never before hit with Adam, or?
Let's check. So there were some sales, not very many. So we had like on the scale of 0-1 or whatever, sales and purchases.
Mm-hmm.
And then let's see with Muon. Yeah, so 0.1, so 5 to 10 times more market activity than before, which is pretty cool.
Interesting.
Well, it's just
That
a
is
better
cool.
model, right? It's higher score. This one is actually, this one will be done in, it's probably still going to be a few hours. 928 billion steps. Yeah, that's still going to be like another 6 hours before this one is done. So this probably won't be done in time for me to look at it tonight, but I'll have it in the morning.
What time do you usually wake up?
Like, I don't know, 8.
You're East Coast, though, right?
Mm-hmm.
Hello?
Yeah, I'm here.
Okay.
Here. This is what I wanted to see. Just take this. $143. Yeah, so this has not really started optimizing correctly yet. What I was trying to figure out here is whether it was enough to just take the PSGD params, or if the other hypers were important as well.
The other hypers meaning?
Well, it tuned a bunch of stuff. Let me go see what it tuned.
I see. You're saying, can you just plop PSGD in with the other RL hypers?
Yeah, or just like the optim, like does it actually care about the other ones a ton? Let's see. So because it reduced the number of M's by half, which is annoying, because that makes it a little slower. And it's now doing 2 gradient steps per update as well, which is also annoying.
Why? Because it's doing. Oh, is this Newton?
No, it's PPO.
Then why is it doing?
PPO, you can do multiple steps per sample, right?
I see. Yes.
But typically, if it's optimized well and your MVIS fast, it should only be 1. Because why use stale data when you can use fresh data?
Yeah, that is weird.
We've got gamma. Gamma lambda aren't like crazy weird. 0.94, 0.86. We've got entropy. Yeah, batch size and mini batch are the same. So presumably it's just got to be like either the entropy or gamma and lambda or the second update epoch. It does look like it's starting to learn here. Maybe. Yeah, but this is nowhere near the original chart.
Yeah, interesting, huh?
Yeah, you can see it's starting to come off right here, but it's at 1.02. So whatever these graphs are doing, some of those hypers actually matter.
Yeah.
It could just be the entropy coefficient, to be fair. How fast does it say that this experiment was running? SPS. It should log SPS somewhere. Well, somehow it says this is running way faster as well than the current. So I don't know how it's running way faster. Oh, I guess this is just PSGD. It takes like a few thousand epochs to get to warm up, doesn't it? Like a few thousand.
In terms of runtime?
This thing is... It says that this is faster than the previous, or than the current configuration, which is weird.
Yeah, that is weird. Maybe because you're running locally?
Could be. I still have a 4090 here.
Mm.
Oh yeah, no, it says from the start it's already at like 500,000. What the hell would this be doing that's faster? I didn't think it was 2 M's, but that should make it slower, not faster. Any batch size the same. None of these other params should affect speed.
Yeah, that's interesting.
Mincom Prof started taking off though. So it is actually optimizing now, it looks like. There you go. This is muon. Yeah, the muon baseline's way down here. So I guess the question then will be, even if this is worse initially, is it stable? Does it intersect?
Yeah, I mean, I think... Yeah, I don't know.
Well, I will try this. I'll let this run for a bit. We'll try like various portions of this. That's my default gamma and lambda. The only thing I can see that's high is the gamma. The lambda is about the same as the optim one. So 0.995 gamma is quite high, but that actually should be better longer term for neural MMO. Entropy is 0.01, so yeah, this 3x higher entropy in the optimized run as well. Let's see, maybe I can get some stats off to this. Okay, so it doesn't look like it's entropy. If I just drop this one. So entropy here, right? We have a good result at 0.003, and we have a good result at 0.03. So it's not very sensitive to entropy. It's not that one. Why did these all say 1 update epoch when it looked like it was 2? That's sketchy. Wait. There's update epochs here. Oh wait, this is 1 update epoch. Yeah, this is 1 update epoch. Okay. I must have been looking at the wrong one. So it's not that then either. The heck else did I sweep? It's gotta be lambda and gamma. Which is consistent with my hypothesis that GAE is the last thing holding us back in RL.
JE?
Generalized advantage estimation.
Let's see.
Built into PPO.
Yeah.
Okay, so here's it saying that you don't do well when gamma is above 0.97. 0.94 to 0.97 is fine. It's probably this right here is this gamma. I don't think it's super sensitive to lambda. I could be wrong. Yeah, so this 0.85 or whatever, this is pretty close to where we have it by default.
Let's see.
So the only thing that's different here potentially is this gamma. So I think I'm literally just going to take this exactly as it is. And then I will let this run for just a little longer. Maybe we do 500 mil as a benchmark. And then I will run this with gamma set to 0.95. And we'll go from there. Let's see the graph in the meanwhile. Oh, so it has it caught up quite nicely, but it looks stalled.
Yeah, maybe.
I mean, I guess Gamma could technically clause that if it just can't figure out credit assignment at all, right?
Yeah, that makes sense.
I have seen this type of thing happen before.
Are you setting your preconditioner init scale to something?
No.
Is it being set to none? Can you double check that?
It's not being passed.
Can you double check if the default is none then?
Well, so this isn't the one because I am actually using the precon to LR in the. I'll go double check from the box that I'm running the sweep on. This one. Where's the box? Too many windows open. Okay, so precon to LR, beta LR, this is all that's being set. You want me to check the heavy ball default?
Yeah.
Init scales 1.
Can you check if that's true in the actual code? You might not have updated the. If so, we should be setting it to none for his.
It is none.
Okay.
I don't know when this is from though. And if he pushed it like today, then it could be off, but.
I think it's from yesterday.
Does this break stuff?
No, it makes things stronger. But if you're there's basically how you initialize your preconditioner, and you can set the scale for it to be initialized at, right?
Yeah.
And so it's basically like it's kind of important to be set to none, and then you should check that in its scale no more than like 2 to 0.5, I think. Probably, maybe more, but we should do it pretty fine. Like it might actually make a difference. We haven't explored it too much, but sometimes we see if the net scale is off, then like it'll completely mess things up.
Yeah, so what I'm gonna have to do here, right, is like let me at least get a decent neural MMO 3 baseline up first, and then I will probably just do a sweep where I do like all of these params. So I'll do the LR, I'll do the precon init scale, I'll have this set to none, I'll do the Mars gamma, I'll do weight decay. Like I can do more of these.
Okay, just get the baseline.
Yeah, the baseline is
that makes
important
sense.
first. So I want to make, because right now I'm kind of iffy on all this, because like something's jank. And I think it's probably just gamma, but I'm not positive.
Okay.
And that bothers me. Because all the other M's work.
Okay. I told Lucas to try a new idea, which is like a hybrid gradient Hessian calculation. And he said that on some of the hardest problems, it reduces the number of trials required. So if we look at this, right, Newton hybrid to PSGD LRA, right, which is probably what you should be using is the LRA versus cron for RL, because cron is like scalable to multiple billions of parameters, whereas you really don't care about that. You really want like a low rank approximation of your global preconditioner. Like, let's see, PSGD LRA without any Newton, right? It was taking 50 attempts. Okay. But with the hybrid, it actually dropped it down from 50 down to 12.
Well, that's
so
cool, but does it run like at a reasonable rate? Because we have to use this is second order, right?
Yes, it is second order, but
it has to be finite difference version.
Yeah, exactly. So he has a finite difference version as well, baked right into the code. So it should just work. You just have to set finite difference to true. And then now he has this hybrid version as well. So we have one thing I'm not sure. So with Newton, your learning rate is going to be different than with non-Newton. And so this is kind of a hybrid first order, second order method. So I don't know where the learning rate is going to end up actually. So it's like, I don't know, Puffer is actually enabling, as you know, like so much experimentation. Like it's such a good framework to do so many like runs that you can actually explore these things in,
that's the goal,
in bulk.
Hey, I know Lucas is at Keen, right? It's like, hey, you guys should use Puffer. It's good.
Yeah. So let's just say Lucas very much likes PSGD, and he's taken a very nice liking towards PSGD LRA, and now he's really, really liking the hybrid version. Yeah.
All right. Well, we will see on that.
Yeah.
My x-axis is probably different from his. I think his x-axis is steps and mine's wall clock. So we'll see if that messes with anything. Well, I can say this isn't stuck as well. This is not stuck, but it's like, it's slower, it looks like, right?
Yeah, but it still looks pretty decent.
Yeah, it's stable. It's just not like... Okay. I mean, that's actually not really any shallower than the slope here. Like, if you look at these runs, right? These runs all kind of do the same thing. And this is just hyperparam. So it's just hyperparams as to how high it gets before it slows down.
Yeah, exactly.
So I think we kill this. I think we try gamma 096 or 095, whatever. Let's see which one I want to do. 095 will do. Yeah, so see this. See if this instantly fixes it. And then if it does, well, we just try these params on everything and know that gamma sometimes has to change. And then that's going to be the case for the new algorithm I've been developing to try to delete gamma and lambda from existence. It's a hard baseline though. It's a hard baseline to beat because basically you have two tunable knobs that tell you how much you care about credit assignment. And to beat that, you have to have an algorithm that learns credit assignment better than a fixed but tuned existing, like, twofold exponential weighting. It's a little tricky.
Yeah, that does sound tricky.
But GAE has to go. GAE has to go. Maybe I can just see it on episode return. This is overlapping with the previous one so far.
I mean, the previous one wasn't horrible, right?
No, but we'll see how the longer term behavior is.
Yeah, exactly.
Because I think this one came off the ground. Some of the better runs from before that we tuned came off the ground earlier. That could be entropy coefficient, though. That could be like a way more trivial entropy coefficient thing.
I've gotten so used to coding with an LLM that when I have to code without it, it's like, wow, this is so slow.
I do not suggest getting overly reliant on these things.
Yeah, I know.
I use SuperMaven for like typing speed buff. That's about it. Hey, thanks for dropping by. See you around. That's cool. Somebody found this from Iceberg video.
Nice.
And this does have like a nice steep. It's gonna just depend where this thing evens out. I guess after this, I have to try entropy. It shouldn't matter though. From the other graph, it doesn't seem like it did. Yeah, so I mean, you can see the best runs. I think it's these two. Make sure the best runs are, in fact, the best runs. I'm pretty sure, yeah, these are the best runs, right? Yeah, so these ones are much steeper there. We're at 130. This thing has not come off of the ground yet. This thing eventually came off the ground, but much later, and it didn't get the same height. Where's PSGD compared to this thing?
Yeah.
I mean, they're all good compared to PSGD so far.
Compared to Muon, you mean?
Muon, yeah.
Yeah, but we really have to see how it's affected later in training. I mean, it's weird to me that this would happen in general, but I mean, we have to just verify what's going on.
Well, at least now we have 1 billion step sweeps, so that gives us like some indication.
Hopefully.
Is this even worse than the previous run? I'm confused. Is it just not? 63. I mean, getting to level 2 average is non-trivial as well. Because that means the average agent, right? So this is an average. So that means that on average, each agent is going to go find an enemy, kill the enemy, pick up the tool, equip the tool, find a resource.
Yeah, on average.
Yeah. So it's not like that's the best agent in there, right? It's like that's like the average behavior is going to get a level and get like equipment and stuff.
Yeah. Wait, that's actually. Okay. This is a question then about the game. Is there finite resources?
They respawn.
There's what?
They respawn.
They respawn. Okay.
Yeah, I'm not that dumb. It's not going to be like there's nothing for them to get.
No, I know, but like,
They collected
there be
everything
some
and then
like
flatlines. No, I didn't. I don't have that.
no, but like, could there be some like I mean, obviously it's a game, so there's some game theoretic things in there, but there could be like some weird thing somewhere where like because of the finite resources, there's like different strategies, like based off of like the like it based off of how fast they spawn. Could there be different strategies? Like could somebody be exploiting that versus like it could be part of the game, right? Okay, every day, like when the sun comes up, something gets triggered, right? Which like makes sense within the game, but that could like dictate a different strategy. Yeah, I mean that makes sense though, right? That's like within the realm of the game.
Well, if they're doing that, then they should be getting higher score. If they found an exploit.
Yeah. That's fair.
Alright, so this is starting to come off the ground. But this looks exactly like the previous curve. So I have a completely different gamma. And it looks just like the previous curve, huh? That seems bizarre to me. Oh wait, am I stupid? Yeah, I'm stupid. I'm really fucking stupid, okay.
What happened?
Wasn't applying the parameters.
Oh, yeah. I have a meme for that.
Okay, I'll try this. Gotta love it. The problem with running experiments is it's very boring. So you end up making stupid mistakes, which is why I try not to have too many days spent doing boring ass experiments.
Yeah, I feel that.
I much prefer building stuff.
I don't know if you have Instagram, but
No.
You don't?
No, stay off of Instagram. There's nothing
But memes.
there's nothing on Instagram but cam girls and bodybuilders.
But memes.
Welcome to x.com.
It's funny, I get different memes on X versus Instagram versus YouTube.
Yes, you get like you get room temperature IQ on X, and you get IQ you have to dig for on Instagram.
Yes. And then on YouTube, it's just like wholesome.
Okay, YouTube is funny.
Yeah.
I found this guy that just like, I'm in Florida, so I guess it recommends me Florida stuff. And there's this guy in Florida that just like runs around grabbing snakes and crocodiles with his bare hands.
Yeah, I know what you're talking about. I mean, I'm sure there's more than one of those guys, but it's super funny.
Yeah. It's just like, damn it, algorithm, stop it.
Stop knowing me so well.
Let's see if this reward curve looks different. Hard to say. Takes a while. I wonder if episode length is a better and less noisy indicator.
Yeah, so Evan does episode length a lot.
It depends. It's M specific.
I see.
Yeah, it's M specific. What matters? That's promising though, right? Let's see. It hasn't synced yet, but that's at what, 74 mil? Is that on par? It might be on par only with the better ones. Let's see. It is slightly above. I don't know whether it's significantly above, but it is slightly above. So I think that it's possible that pattern was a function of beta and the precont LR instead of gamma. It's possible.
I see.
See, like the best runs, they actually just keep going. The slope. Yeah, I'm a little suspicious with the slope because these ones like the curvature is different, I think. Which is a little bit sus. Like the good runs have this accelerating curvature.
Okay. I see what you're saying.
It might still need the gamma, we'll see. If it doesn't work with the correct params and gamma though, then I'm not sure.
I mean, not to ask a stupid question, but if you have protein, why would you do this?
Why would I do what?
Why are you hand tuning?
So protein is picked coefficients for us, right? So protein gave us this run. These runs up here. But this is tuning everything. So this is me just trying to figure out, I'm trying to understand which of these parameters really matter and which ones don't as much. So like if I can get something that roughly matches here without having to tune all the parameters, that's better. Right? So I'm trying to just like get a feel for the robustness of the optimizer. Once you have it like set to specific optimizer params, does it only work in a narrow band of gamma? Does it only work with like a specific entropy or something? That's what I'm trying to figure out.
You're just doing sensitivity analysis, basically.
Basically, I'm also just trying to get a feel for the thing. Stuff just feels janky in RL. So most of the time I do automated stuff, but every so often I just like to poke things until they make sense. Pretty much what this is. See, like this is definitely below the other ones. I'm gonna give it a little longer, but let's just fill in. Yeah. See, that's on par with the other ones. So this is now with the correct preconditioning. For each PSPD cron, LR, precon LR, and atom beta 1. The thing that bothers me here is that I would think that the higher gamma would be better long term. It's possible that it's just preventing you from learning anything really.
I see.
I just basically I wanted to see if this like if the curves separate from this and oh hang on. Is that something right there? That seems to be separation. It's very mild if it is though.
Mm-hmm.
Let's look at mid-com prof because this is the actual metric that we care about. Oh, hold on. We do have separation. Look at that. You see?
I see.
Look at that. So this is there's a dramatic difference. Okay, so episode return. Yeah, so that's a dramatic capabilities difference. So now the only other ablation I have to run is the gamma.
Wait, so what did that mean? That means that
This means that right now, like say 15% of the agents are defeating an enemy and then getting harvesting an item, harvesting a resource. So yeah, that is capabilities difference right there. So the precon and beta actually make a huge difference because that's all that changed here, precon and beta. Kill this. I want to test the gamma because I want to see if that's like the massive separation difference. I just want to sort of think about this in the meantime. I guess it's kind of weird that I had gamma so high in the first place. That I got that from breakout. That's a very, very high gamma though to have. I guess. Okay. Let's see if I can figure something out from that though. That's your clue. How high does gamma get before stuff breaks? You know, I'm looking at this now, and there's definitely a correlation here. But you can see 995 gamma, it still does something. So if we use this as a proxy for what we're likely to get, I mean, that's kind of what we want. It's whatever default gamma we set will work, but you'll get better results with a more finely tuned gamma. I think I would rather do 0.98 though than 0.995 if these both work. Actually, let me see. So this is the, we've got 0.9, we got these two. So this is a dark blue, and we've got this one. If I go to these charts, it's a dark blue. This is the dark blue right here.
Okay.
So that's interesting, right? So the dark blue is the higher gamma. That looks like that's going to do better to me. That's got like the much steeper. This is linear, this is logarithmic.
Yeah.
So I actually think that, yeah, I'm just going to let this run for a couple minutes then just to see if early behavior changes based on that.
Okay.
But I think gamma definitely does matter. It would have to, just based on how PPO works. And I think it is possible that, like what might have been happening before with the sweeps, is that if you run too short of an experiment, right? If you run a 500 mil experiment, it'll look like this one's way better. But if you run it longer, they catch up.
Yeah, exactly. Right.
Well, this is why I did 1 bill, which is like, I mean,
could be enough.
That's way longer than the x-axis of the vast majority of papers, right? Like, there's still papers published today that have an x-axis that's 1 million. Or 10 million. 10 million is a very common x-axis.
I would love to publish a few papers on Puffer then.
Okay, go for it.
If that's, yeah. Like, even if we just get your reports that you have in the past and we just turn them into papers, I'm sure they'll publish.
I'm not sure they'll publish. Academia is fucking stupid. And I am so sick of dealing with academia. It's like, oh my god. This is why I collab on projects. Sometimes, you know, people, like, I'm on NYU submission at the moment, but it's like dealing with academia is so obnoxious. The review process is just, it needs to go. It's just like you're wasting hundreds to thousands of hours of everyone's 20s.
I submitted a paper and the reviewers, like, it seems you guys have done Nesterov momentum. And we're just like, dude, you don't know the difference between Nesterov momentum and heavy bulb momentum? Why are you reviewing this paper? And why do you have at least?
We got one that was, this sim doesn't seem good because it's in C++.
What?
It's like, this seems hard. Your sim's written in C++.
Yeah.
For the GPU drive stuff at one point.
That's really funny.
I mean, Puffer got double rejected, and then I said, fuck it. Right? It's like, all right, you know what? I gave you clear cut, like, even the early versions of Puffer, right? Where it's like, I made vectorization like 50% to 100x faster, depending on your M, just across the board. Drop in, use it with anything. Also supports multi-agent out of the box. They're like, yeah, nah. We don't publish software. We prefer to write really bad code and feel self-important about it.
Yeah, so that's the thing. I'm like the first person to say, like, I'm not the #1 coder in the world. you know,
Uh,
and that's all right. But kind of pisses me off when people who have people who like refuse to use good software, and it's like, why are you doing this?
mm-hmm. And I tried to keep all this stuff in Puffer pretty good. It's well, to be fair, there's a lot of stuff, so some stuff needs to be looked at and cleaned up by now. I think that project with the new PRs is going to be close to 40K lines now. I think that's like the size of WhatsApp or whatever. What happened here? Does this do worse? Did it increase gamma or something? See, this is unexpected. This is what I don't like. If I just ran this and it does what I expect, then it's like, oh, okay, I get it. But now that's doing something that doesn't make any sense. Actually, maybe this one was good. Let's see. You know, if you look at this one on the min-com prof scale, this actually had, we were looking at episode return. This one actually looks very good.
Interesting. Excuse me.
So setting gamma to 0.95 breaks it. A little weird because you can get rewards. Well, the whole getting Mincom Prof is, that's probably like a 50-step process at least to get that up. But you can get intermediate rewards in like 10 to 20 steps. Interesting. That bothers me. Maybe the call is to just run the high gamma version. I'm trying to think though, 995 is like a very high gamma to be running with, even for this. I mean, especially for this, it's not like, it almost makes, it makes more sense for breakout than for this, honestly. Because like 2 seconds of breakout's like 120 frames. So like, yeah, maybe 995 is good for that. But I mean, for this one, like, I guess what I don't understand is how is this one way down here? If this light, what did this set? This set 0.95 as well. So why does it not work here? This is the one, right? This is the curve. We almost have the virtually the same hyperparams now on this. So now this does come up eventually. See, the reason I do this is not to get the result. Like, yeah, it's way quicker to run the sweeps. I'm trying to develop some intuition around these things and see if they behave in a predictable way.
Yeah, I hear you. That makes sense.
Well, at the very least, compared to before, this is a qualitative difference. Like these. Well, is it
Oh, wow. That's really going up that gray one. Yeah.
gray one? This one, yeah. See, this is what we did before.
Yeah.
But then, like, we change it to this param, which is supposed to be closer to this one here.
Yeah, I mean, there might be like pockets of good hyperparameters, right?
There shouldn't be with the way that these work unless they're like correlated in some weird way. Yeah, it's tough because like the thing that really matters is the long-term behavior of this thing anyways.
Yeah.
I remember, so 0.995 did break. It broke a couple of the really short horizon tasks. I think I'm tempted to just run this 0.99 or whatever, and then just go get dinner. I'm trying to think if 995 can do anything. 995 200 steps. Like, I don't think the network has capacity to reason over 200 steps. But it worked in Breakout. Fine. I think we'll just leave. Let's just leave the default. Or let's do this. I mean, this will be the best case anyways, because if this works, then I think we're all set. So I'm going to do one thing before I do this. I want to run Breakout. See if this actually solves. Oh, and actually, hold on, you have to copy these params in too. Copy these params to Breakout. I just want to see if these are like good general params. Yeah, so something broke here in the process of doing this.
How do you see that?
What? Well, this is not, the max score is 800. So I think the default learning rate was 0.01 or something, wasn't it? 0.01 or 0.001?
For what? Sorry.
The default learning rate for cron, heavy bulk cron. Let's see. We'll check.
Not sure.
001, so I have it way too high, most likely. It does seem to actually optimize though, which is funny. Okay, so literally just changing the learning rate. No other changes. Now it works on breakout.
Nice.
10x higher than the default though. But 001, does this still work or does it break? I'm trying to think why different M's. Is there a good reason different M's should need a totally different learning rate still?
I don't know. I mean, I guess it's like, how far off are the learning rates?
I mean, it's 0025 or 0.01. Let me see.
I don't know.
It's a pretty big
The
gap. Yeah,
defaults
it doesn't,
should.
and it's weird. I think you're right with the pockets because it doesn't optimize at all with this. So like I had it on 0.0. You know, on 0.01 it optimizes. Interesting. Okay, well, I'm gonna have to run neural MMO3 with Neptune, and I will come back and check this after dinner.
Nice.
And we'll see how this is. And then I'll get a full run of this going once I get the machine back from the Muon baseline. And we'll see whether this beats Muon, which is not fully tuned to Muon, to be fair. They both have 3. cool thing, I doubt Muon is gonna like have the same learning rate for neural MMO magically though as everything else either. I don't think there's anything in Muon that lets you do that.
Yeah, I don't know. Keller says it should all be the same learning rate, but it's not just not true.
I mean, we just see in practice it doesn't work. But I like the preconditioned learning rate in beta, I wonder about. Okay, well, I'm gonna go get some food. I've been boring myself out of my mind thinking about this for the last few hours. I still want to implement the
This is
caching. Good. Mars should not fix. Like Mars should not give you mini batch size in invariance. I'm assuming. Right.
You're saying your hyperparameters should stay constant with respect to your mini batch?
So Mars is Lucas said, "Oh yeah, try Mars," because I was talking about mini batch size and like how I needed to add gradient accumulation for larger to enable training with larger mini batch sizes. I mean, I ran some experiments earlier, and it seems like mini batch size really does matter. It's not just like you can't just like you can't just cut your mini batch in half and drop the learning rate. It does seem that there is something to just training with more gradients. I would, why.
If this is the case, we can make versions of PSGD that are RL specific. One thing, for example, actually having smaller batches would help PSGD. Not that it would help it, but I don't think it would hurt it. So I think you could just in general try dropping the batch size with PSGD and running maybe another. Yeah, just see what happens and run another protein and then enable Mars. Because Mars does variance reduction.
Efficiency. Like that actually really hurts hardware efficiency. Because
what does?
Dropping the batch size. The only thing you could drop is the mini batch size.
Sorry. The mini batch size. Yes, the mini batch. Dropping the mini batch.
You can only drop it to like the lowest you would drop it is like 8192.
The mini batch.
Mm-hmm. If you drop it any lower, it's just like you're just burning hardware cycles. Like the GPU just doesn't. You're just not using the GPU efficiently.
Yeah. No, we could try dropping it and the mini batches and just seeing. The one thing that you might want to do is you might want to, okay, when you're calculating the preconditioner, right, instead of passing in the batch gradient, right, you can also consider passing the mini batch gradient instead. So I don't know how it's set up to do it right now with your code base, but that might be something of consideration.
I would assume it is getting the mini batch gradient because we never actually compute the gradient of the whole batch.
Okay. Okay, so then that should be fine. I mean, yeah, you can try throwing Mars on it. It's just you have to pay for the memory.
That's fine.
Yeah.
I mean, I think what we'll do is we'll get the good baseline and then we'll run a couple just individual ablations with a couple of these like Boolean flags like Mars, and then we'll probably do a sweep on the constant or the continuous params. Now the thing that I was hoping we could get, which was we were so close with Muon, and I assume we'll probably be able to do similar with PSGD, we had pretty much one set of hyperparams that worked on every env except neural MMO3.
I mean, that was true of PSG, right? That's what you're saying?
Well, it was true of Muon. We haven't fully tested with PSGD yet. So the question is, can we get some hyperparameters that are at least decent on just about every env out of the box?
I see.
With the exceptions potentially of gamma and lambda, because I'm going to be working on that separately.
Mm-hmm.
That's kind of hard. But yeah, with the exceptions of those, I think we should be able to do it. Let's see. Where's our experiment here? I'm just making sure this is set up correctly and running before I go. Okay, but this is not supposed to come off the ground yet, so this is fine. Okay. I'm gonna go get some food, and then I'm gonna come back, and I'm not going to babysit experiments because it's friggin' boring. We're probably just gonna implement gradient accumulation, and we'll go from there.
Sounds good.
Thanks for hanging out.
Thanks.
We'll be running more tests on this. I think what I'm gonna do with this at the moment is I'm gonna just like keep running the stuff on neural MMO in the background. I'm gonna do deal with a little bit of other work, other things I gotta deal with, and then we'll come back when we have sweep results. And I mean, hopefully this thing is good. I'm gonna have to look at the math at some point of this versus Muon to understand what the heck it's doing.
Yeah, I can teach you. We can do a stream or something. We can go through the math.
Sure. All right. Thanks, man. And
Herman,
see you around.
Thank you for